In the forests of eastern North America, in the warm, dark beneath the soil, something is waiting. It has waited for 17 years. It has never seen the sun, never opened its wings, never made a sound. And yet on a single evening, when the ground reaches the exact temperature it has been counting toward for nearly 2 decades, it will rise by the billions, and the forest will fill with a sound that drowns out everything else alive. This is the cicada. Not one insect, but a tide of them. A creature that spends almost its entire life underground, in silence, then erupts into a few frantic weeks of noise and flight and death. It does not bite. It does not sting. It carries no venom and hunts nothing. And still, when it comes, it overwhelms a landscape so completely that early settlers thought the world was ending. What follows is 100 facts about the strangest clock in nature, an animal that measures time in prime numbers, that buries itself for longer than a child takes to grow up, and that emerges all at once, for reasons science is still working to explain. It begins, as it always does, with the sound. Stand in a forest during a full emergence, and the sound arrives before you understand it. It is not chirping. It is not the soft pulse of crickets at dusk. It is a wall, a dense metallic roar that seems to come from every direction and from no single point. Male cicadas, singing together by the thousands, produce a chorus that can reach 100 decibels. That is the volume of a chainsaw held at arm's length. That is loud enough to cause hearing damage with long exposure. A single cicada is loud. A field of them is something else entirely. The sound stacks voice on voice until it stops being a collection of insects and becomes a single, overwhelming presence. Researchers measuring emergent sites have recorded levels that rival a rock concert, a jet on approach, a power saw biting into wood. And here is the strange part. The creature making this noise weighs less than a paperclip. Its body is no longer than a human thumb. The volume comes not from size, but from design, the sound organ unlike anything in the mammal world, which we will come to. For now, only the effect matters. From above, the canopy looks ordinary. Green, still unremarkable. The roar gives no clue to its source. It simply fills the air, pressing in from all sides, a sound with no visible mouth. People who live through an emergence describe the same thing. You stop hearing it as insects. You start hearing it as the forest itself screaming. The number is the part people cannot hold in their minds. When a brood emerges, it does not arrive in the thousands or the millions. It arrives in the billions, sometimes trillions, across a single region in the span of a few nights. Picture an entire state. Now picture every wooded acre of it producing cicadas at the same time, from the same buried signal on roughly the same evening. That is the scale. Brood emergences have been estimated to push past 1 trillion individuals across their full range. There is no human event that compares cleanly. The closest you can reach for is something like every grain of sand on a long beach, standing up and taking flight at once. They do not trickle out. That is what unsettles people. A trickle the mind can manage. This is a flood. The ground that held them all those years opens in countless small holes, and they pour upward through the dark climb, the nearest vertical surface, and wait to transform. What makes it possible is the waiting. For 17 years they grew slowly, separately scattered through the soil, and they held. They did not emerge early. They did not emerge in pieces. They saved themselves for one synchronized moment, because arriving together is the entire strategy. We will see why that matters. For now, stand in the middle of it. Billions of lives, paused for nearly 2 decades, all spending themselves in the same brief window. The forest does not adjust to it gradually. One night there is nothing. The next there is everything. Spread across a region, 1 trillion cicadas is an abstraction. Pressed into a single acre, it becomes physical. In the heaviest emergence zones, densities climb past 1.5 million cicadas in the space of 1 acre, a patch of ground smaller than a football field. Do the arithmetic on your feet, and it stops being a statistic. That is dozens of cicadas on every square foot. Every step you take puts your shoe down among them. Every tree trunk wears them like a second bark. Every fence post, every mailbox, every blade of tall grass holds a body and another above it and another above that. At that concentration, the insects stop behaving like individual animals and start behaving like weather. They coat surfaces. They fill the air when disturbed, rising in clumsy, blundering clouds that bump into your face and tangle in your hair. They are not aggressive. A cicada has no interest in you and no means to harm you. But at 1.5 million per acre, intent stops mattering. Sheer number does the work. From above, a heavily infested tree loses its shape. The trunk darkens. The lower branches thicken with movement. Up close, you can watch them climb over one another, in slow competition for space, indifferent, single-minded, packed shoulder to shoulder in a way that no large animal ever is. This is the density that breaks people's composure. Not danger, there is none. Just the overwhelming arithmetic of too many living things in too small a space, all of them yours to walk through. There is a specific moment people remember from a major emergence, and it is not visual. It is the moment they try to speak to someone standing beside them and fail. At peak chorus, cicadas can make ordinary conversation impossible. You raise your voice, the sound swallows it. You raise it again, nearly shouting, and the person 3 feet away still leans in and shakes their head. Phone calls become useless outdoors. People retreat inside and shut the windows, and even then the roar presses through the glass, muffled but constant. A pressure on the ears that does not let up from dawn until dusk. This is not a brief crescendo. During the weeks of peak emergence, the chorus runs through the warm hours of every single day. It becomes the baseline of existence. Some people describe a kind of fatigue that sets in not from the cicadas themselves, but from the sound, the relentlessness of it, the way it refuses to pause long enough for the mind to rest. Up close in a chorus center, where the males gather thickest, the volume can cross the threshold where hearing protection genuinely matters. Researchers who work in these zones wear earplugs. Field biologists have described the disorientation of standing inside it, the way a sound that loud and that constant stops feeling like sound and starts feeling like a physical place you are trapped inside. And the creatures producing it are not even aware of you. The song is not aimed at humans. We are simply standing in the middle of a conversation meant for someone else. Most natural sounds settle the human nervous system. Bird song, running water, wind in leaves, we are wired to find them calming. The cicada chorus does the opposite, and people are often surprised by how strongly it affects them. There is something in the quality of the sound that reaches past the rational mind. It is not a threat. People know intellectually that the insects are harmless, and still standing inside a full emergence, many feel a low, persistent unease, a sense of being surrounded, of something being deeply off. The volume is part of it. But so is the strangeness, a sound with no clear source, no rhythm to latch onto, no break. Some of it may be ancient. A massive, droning, all-encompassing noise is the kind of signal that across deep history meant something significant was happening. A swarm, a shift in the environment, a thing to pay attention to. The body responds before the mind can reason it away. Stand in it long enough and you notice your own shoulders tighten. The sound has a pulsing quality, a rise and fall, as different groups of males surge and ebb, and the pulse can feel almost intentional, as if the forest were breathing around you. It is not. It is the mathematics of thousands of independent singers drifting in and out of sync. But knowing that does little to loosen the grip. This is the cicada's strange power. It harms nothing, hunts nothing, threatens nothing, and it still manages to make a person standing in a sunny forest feel somewhere underneath thought that they should leave. On the night of emergence, the strangest sight is not in the trees. It is at your feet. The soil begins to open. Across the forest floor, small round holes appear, each one the exact width of the creature that dug it, each one a tunnel that reaches down through years of packed earth. And from these holes, one after another, the nymphs climb out. Not a few, not a scattering. So many so close together that the ground itself seems to crawl. In the worst lit hours after dusk, people describe looking down and seeing the earth shift as if the surface had come loose. It is movement without obvious cause, a low collective, stirring across every open patch of soil. Thousands of pale bodies hauling themselves up into the open air at once. Around the base of a single mature tree you can find hundreds of exit holes. So densely packed, the ground looks aerated, punched through like the surface of a sponge. There is a particular horror reserved for things that should be solid and are not. The ground is supposed to hold still. During emergence in the heaviest zones it does not. It seethes. The nymphs move with a slow, blind determination, climbing over soil and leaf litter and one another, all of them driven by the same buried instinct toward the nearest vertical thing they can climb. Watch one hole for a moment and you see it clearly. A pale head pushes up through the dark, then the body. Once the nymphs reach the trees, they climb, and they do not stop until they find a place to grip. In a heavy emergence, there are not enough places. The trunk fills first, then the lower branches, then every surface the climbing bodies can reach, until the tree wears a living skin of cicadas so dense that the bark beneath simply vanishes from view. You cannot see the wood. You cannot see the texture of the trunk. You see only insects pressed together, climbing over and around one another in a slow upward churn. Stand close, and the tree seems to shimmer. The movement is constant but small, a flexing, a shifting of countless legs and bodies, a surface that is never quite still. Reach out, and the bark you expect to feel is gone, replaced by the dry rustle of overlapping wings and shells. And then a second layer forms over the first. As the nymphs molt and the adults emerge, the discarded shells stay clamped to the bark where they were shed empty and pale and stuck fast. Now the tree carries both the living cicadas climbing and the ghostly husks of the ones who came before, layered together until the whole trunk looks upholstered. From a distance the tree looks diseased. The color is wrong, the shape is softened, thickened, blurred. Walk closer, and the blur resolves into bodies, thousands of them, and the realization arrives all at once. This is not a tree with insects on it. For these few weeks, it is a structure made of insects with a tree somewhere inside. The chorus does not fade gradually. The cicadas live their few weeks above ground, they mate the females, lay their eggs, and then across the same compressed window in which they arrived, they die. All of them, billions at once. And the forest which had filled with sound now fills with something else. The bodies drop. They collect at the base of every tree, in every gutter and ditch and low spot, piling in drifts that can reach several inches deep. And as they break down in the summer heat, they release a smell, thick, sweet and unmistakable, the dense odor of decay multiplied by an almost incomprehensible number of small bodies. People who have lived through the end of an emergence describe the smell as the part that lingers in memory longest. The sound was overwhelming, but the sound at least you understood. The smell is more intimate. It gets into the back of the throat. It hangs in still air. It seeps into neighborhoods, settling over yards and porches and parked cars. A reminder that the spectacle of the past weeks has a second half, and the second half is rot. There is a grim arithmetic to it. 1 trillion creatures emerge. 1 trillion creatures die. The mass of all that life returned to the forest floor in the span of days has to go somewhere, and what it does is decompose all at once in the open. It is not a clean ending, but it is not waste either. We will see later what all that returning matter does for the forest. For now, only the smell hanging in the warm air where the roar used to be. The emergence reaches the roads, and the roads do not handle it well. Cicadas are poor blundering flyers. They lift off heavily, drift without much control, and crash into whatever stands in their path, windshields, grills, the sides of passing trucks. During a major emergence, drivers report a constant soft impact against the glass, a steady patter of bodies through the warm hours, enough to smear the windshield and force the wipers on under a clear sky. But the real problem is the ground. Where cicadas gather thickest near roadways, their bodies living and dead accumulate on the pavement, and crushed by traffic in sufficient numbers, they turn the road surface slick. There are documented cases of roads made genuinely slippery by the sheer volume of cicada, remains the way a road slicks with wet leaves in autumn. Except the slick is made of insects. Picture the scene from above. A country road in early summer, dry and sunlit, and yet the surface glistens, a greasy sheen of countless small bodies, pressed flat by tires, accumulating faster than the traffic can clear them. It sounds almost comic until you are the one driving through it. The patter against the windshield, the smell working through the vents, the faint loss of grip on a road that should be dry. None of it is dangerous in the way a predator is dangerous. The cicada is still doing nothing to you on purpose, but the scale of it intrudes on ordinary life in ways that are hard to prepare for the moment your tires lose a little of their certainty on dry pavement for no reason your eyes can immediately explain. Before you reach an emergence, you hear it. Long before the trees come into view, before you see a single insect, the sound arrives across open country, a low, steady drone carried on the air from miles away. It does not announce itself sharply, it builds. You are driving or walking, and you become slowly aware of a sound underneath the ordinary, sounds a hum at the edge of hearing that you cannot quite place. You turn the radio down. It is still there. You roll the window up. It comes through. As you draw closer, the drone thickens and rises, separating into its countless voices, until what was a distant hum becomes the full roar of the chorus. The reach of it is the unsettling part. A single insect makes a sound you can barely hear across a room, but the chorus, millions of bodies singing in loose unison across a forest, generates a volume that crosses open fields, rolls over hills, and arrives at the ears of people who are nowhere near the trees. Residents near major emergence zones describe hearing it from inside their homes. Doors closed as a constant background presence for weeks. From the air, you could map the emergence by sound alone. A wide zone of drone fading at the edges, marking exactly where the brood has come up. No fence shows the boundary. The sound shows it. And standing at that fading edge where the roar thins back into an ordinary summer afternoon, you can hear with strange clarity the line between the world the cicadas have taken over and the world they have not. Every predator in the forest responds to an emergence the same way. They feast and then they quit. Birds, raccoons, foxes, squirrels, snakes, fish, domestic pets, even the family dog when cicadas blanket the landscape. Nearly everything that eats meat eats cicadas. They are slow, soft, defenseless, and lying everywhere in reach. For a predator, an emergence is the easiest hunting of its life, food that does not run, does not fight, and arrives in quantities beyond any appetite. And that is exactly the cicada's defense. There is a limit to how much a bird can eat. A predator gorges, fills itself completely, and stops, and the cicadas keep coming in numbers so vast that the combined hunger of every predator in the entire region barely makes a dent. The math defeats them. You can eat your fill 10 times over and the ground is still covered. The trees are still loud. The supply is for all practical purposes infinite. Scientists call this strategy predator satiation, and it is the whole reason the emergence happens the way it does. By arriving all at once in overwhelming numbers, the cicadas guarantee that predators will be stuffed to capacity long before they can threaten the population as a whole. The individuals eaten number in the millions. It does not matter. Millions eaten out of trillions is a rounding error, and the survivors are left in peace to mate and lay the next generation. It is a defense built not on weapons but on arithmetic. No armor, no venom, no speed. Just the cold logic of being too numerous to finish. What disturbs people most is not the scale, it is the suddenness. An emergence does not creep up over a season. There is no slow building of numbers, no gradual increase that lets a person adjust. For 17 years, the forest looks completely ordinary. The cicadas are there the whole time, millions of them directly underfoot, but they are below the soil, invisible, silent. You could walk that ground 1,000 times and never know. Then the conditions align. The soil reaches the temperature the nymphs have been waiting for, and in the span of a single warm night they come up, not a few as scouts, not a slow leading edge, but the whole brood surging to the surface together. You can go to sleep in an ordinary forest and wake in a transformed one. The change is that fast. One evening, nothing. The next morning every tree wears a coat of climbing nymphs, every surface holds a shell, and the first males are already tuning their song. By afternoon the roar has begun. There is something deeply unsettling about a change of that magnitude, arriving without warning. We expect large events to telegraph themselves. We expect a build-up. The cicada offers none. It spends nearly 2 decades giving no sign at all, and then delivers everything at once overnight, with a precision that feels almost deliberate. For the people who live through it, the abruptness reframes the ground they walk on. The forest they thought they knew was holding 1 billion lives in waiting the entire time. They simply could not see it until the one night it decided to show them all at once. The roar that fills the forest comes from a structure no mammal possesses, and it works in a way that has no parallel in the human voice. The male cicada does not sing with breath. On each side of its abdomen sits a structure called a timbal, a curved plate of stiff ribbed membrane. Muscles attach to the timbal contract and snap it inward, and the plate buckles with a sharp click. Release, and it pops back. Contract again, and it clicks once more. Each individual click is tiny, but fired in a rapid stream, the clicks blur together into the continuous piercing tone we hear as the cicada's song. It is closer to the rapid buckling of a tin lid pressed in and out at impossible speed than to anything a throat can do. What makes it loud is what sits behind the timbals. Much of the male's abdomen is hollow, an empty chamber that acts as a resonator, catching the sound the timbals make and amplifying it the way the hollow body of a guitar swells the sound of its strings. The male is in effect built mostly as an instrument, a relatively small engine driving a large echo chamber. The result is a sound that, pound for pound, may be among the loudest produced by any animal on Earth. A creature the size of your thumb, generating a tone you can hear across open fields. And every one of those millions of voices in the chorus is made the same way, not by lungs, not by vocal cords, but by a plate of membrane snapping in and out hundreds of times a second. Inside a hollow drum of a body, it would be easy to see the emergence as chaos, 1 billion insects blundering up out of the ground at random. It is the opposite. Every overwhelming feature of it is a weapon honed by deep time. The numbers are not an accident. The synchrony is not an accident. The fact that they all arrive together in quantities that defeat every predator at once is the entire point of strategy so effective it has kept these insects alive, in essentially this form, for an immense stretch of evolutionary predator history. Consider the alternative. If cicadas emerged a few at a time, spread across the years, predators would learn to expect them. A reliable trickle of slow, defenseless insects would become a dependable food source, and the predators would tune their own numbers to match it. The cicadas would be eaten as fast as they appeared. The population would never get ahead. By collapsing all of that emergence into one brief, massive pulse, the cicadas break the system. Predators cannot stockpile the feast. They cannot eat fast enough. They cannot raise their own numbers in advance because the cicadas give them nothing for 17 years and then everything in a single week. There is no way for a predator to prepare for a meal that arrives once every 17 years and vanishes in a month. So the overwhelm is not a side effect. It is the design. The unsettling scale that breaks a person's composure is the same scale that keeps the species alive. What looks like madness from the inside of the swarm is, from the long view of evolution, one of the most elegant survival strategies in the natural world, a defense made entirely of timing and number. When the first European settlers in North America met a periodical emergence, they reached for the only frame of reference they had. They thought it was the end of the world. In the early colonial records, there are accounts of settlers seeing the ground erupt, with insects hearing the rising roar, watching the trees vanish under climbing bodies, and concluding that they were witnessing one of the plagues described in Scripture. They called them locusts, the same word used for the devouring swarms of the Old Testament, and the name stuck so firmly that many Americans still call periodical cicadas locusts today, though the two insects are entirely unrelated. The mistake is easy to forgive. Imagine arriving in an unfamiliar land, and one morning the soil opens and disgorges insects beyond counting, and the air fills with a sound like nothing you have heard, and within days the forest is transformed and the bodies begin to compile. Without the science we now have, without any idea that these creatures had been waiting underground for 17 years, what else would you conclude but that something divine and terrible was unfolding? There is a thread that runs through human history of meeting the cicada emergence with dread. Different cultures, different centuries, the same instinctive response: this is too large, too sudden, too strange to be ordinary. It must mean something. We know better now. We know the timing, the biology, the long patient arithmetic underneath it. And yet the settler's reaction tells us something true that the science does not erase. Stand inside a full emergence, stripped of explanation, and the oldest part of your mind still reaches for the same word they did: plague. Look closely at a single periodical cicada, and one feature holds your attention: the eyes. On the most familiar broods, they are a deep, glassy red, set wide on the sides of the head, large and round, and startlingly vivid against the dark body. On one insect, the red eyes are merely striking. Multiplied across an emergence, they become something stranger. When a tree is coated with thousands of cicadas, it is also coated with thousands of pairs of red eyes. All of them open, none of them blinking, all faintly catching the light. Lean in toward an infested trunk, and the impression is unmistakable, a surface that is looking back. There is no malice in it. A cicada's eye is a simple organ tracking light and motion, not studying you. But the human mind is built to find eyes and to react to them, and a wall of unblinking red eyes trips that instinct hard. The color does most of the work. Red reads to us as a warning blood heat alarm. Cicadas wear it not as a signal to humans, but as a quirk of their pigmentation, and not even all of them. Some broods have blue eyes or white or rare individuals, with eyes of unexpected colors that collectors prize. But the common red is what people remember, because red eyes in their thousands, staring out from every surface of a darkened tree, sit somewhere very deep in the catalogue of things the human brain flags as wrong. Up close in the right light, a single cicada's eye is almost beautiful, a polished bead of dark crimson. It is only the multiplication that turns beauty into unease. One red eye is a curiosity. A forest of them, unblinking, is something else. When the nymphs come out of the ground, they are driven by a single blunt imperative climb. Find something vertical, grip it, and go up. And in a heavy emergence, they do not discriminate about what that something is. Trees, of course, but also fence posts, lamp posts, brick walls, car tires, garden tools left leaning in the yard, the legs of patio furniture, the sides of houses, the stems of flowers, each other. Anything that rises from the ground and offers a grip becomes a ladder. People walk out in the morning to find their porch railings furred with climbing nymphs. Their parked cars wearing them up the doors, the swing set in the yard transformed into a scaffold of slowly ascending bodies. The instinct is ancient and inflexible. The nymph has spent 17 years underground for this moment, and now it needs height a place to anchor itself for the final molt, where it can split its old skin and pull free as a winged adult without the ground's dangers. So it climbs whatever it finds blindly, with the same patient determination it has carried its whole life. Stand still in the middle of it, and you may feel a faint tug at your own pant leg. A nymph finding a human standing motionless will climb a person as readily as a post. It means nothing by it. You are simply the nearest vertical thing. From a little distance, the effect is surreal. An entire built environment, the ordinary furniture of a backyard, suddenly pressed into service as climbing structures for an insect that does not know or care what any of it is. The world becomes briefly nothing but surfaces to ascend. There is a sound from an emergence that is smaller than the roar and far more personal. It happens under your own feet. In the heaviest zones, cicadas and their discarded shells cover the ground so completely that walking becomes impossible without stepping on them. And they crunch. Dry, brittle, hollow the shells and bodies give way under a shoe with a sound like crushing autumn leaves. Except the leaves are insects and there is no way to avoid them. Every step delivers it. A soft splitting crackle, over and over, the entire length of a walk. People describe an involuntary recoil the first time they feel it, the body's instinct to lift the foot to find clear ground, to not crush a living thing. But there is no clear ground. The density removes the option. You can stand still or you can walk and crunch. After a while, the recoil dulls into grim acceptance and you simply move through it, accompanied by the steady sound of your own footsteps breaking small bodies underneath you. It is one thing to see an overwhelming number. It is another to feel it transmit up through the soles of your shoes. The crunch makes the scale physical in a way the eyes alone cannot. Each footstep is a small accounting of just how many there are, because no matter where you place your foot, there is always something there to give way. Groundskeepers and gardeners describe sweeping the shells into piles, shovelfuls of empty husks, and the piles refilling by the next day. There is no clearing it while the emergence runs. The ground belongs to the cicadas, and you walk across it on their terms, one crunch at a time. For the animals of the neighborhood, an emergence is a feast without limit, and many of them do not know when to stop. Dogs are the classic case. To a dog, a yard full of slow, crunchy, protein-rich insects is paradise, and a dog left to its own devices will eat cicadas by the dozen, by the hundred, gorging, until its stomach simply cannot manage the volume of shells and wings. Veterinarians in emergence years see a steady stream of dogs sick from overindulgence, not poisoned because cicadas are not toxic, but overwhelmed, their digestion swamped by sheer quantity of crunchy exoskeleton. Wildlife does the same. Birds eat until they can barely fly. Raccoons and opossums and foxes feast nightly. Fish in the streams grow fat on cicadas that blunder onto the water. Across the whole web of local animals, the response is identical: eat and keep eating, because a bounty this large and this easy will not come again for 17 years, and the body does not have a setting for restraint in the face of it. There is a dark comedy to the family dog waddling in from the yard, visibly unwell, having treated the emergence as an all-it-can-eat buffet and badly misjudged its own limits. The cicada, even in being eaten, manages to overwhelm. And underneath the comedy is that same strategy at work. The cicadas want to be eaten, not the individual, but the population can afford to lose its millions because there are simply too many to finish. The gorging animals, sick and stuffed and still surrounded by more food than they can touch, are living proof that the defense is working. The predators have eaten themselves to the edge of illness, and the cicadas have barely noticed the loss. Gather all of it together: the roar that drowns your voice, the ground that opens and crawls, the trees that vanish under bodies, the crunch underfoot, the red eyes in their thousands, the smell beginning to rise and stand in the middle of it. What you feel more than anything is helplessness. Not fear exactly. There is nothing to fear. No bite, no sting, no danger to your life or your body. And that is precisely what makes the feeling so strange. You are surrounded, overwhelmed, outnumbered beyond comprehension by creatures that mean you no harm and pose you no threat, and still there is nothing you can do about any of it. You cannot quiet the sound. You cannot clear the ground. You cannot make the trees give back their shape or pull the smell out of the air. The emergence simply is at a scale that dwarfs you, and it will run its course on its own schedule regardless of anything you do. That is a rare feeling in modern life. We are used to managing our environment, shaping it, shutting things out. The cicada emergence cannot be managed. It is too large, too numerous, too indifferent. You close the windows and it comes through the glass. You sweep the shells and they return by morning. You wait for quiet, and the roar runs on day after day for weeks. And so you are left to simply stand in it, small, surrounded and powerless before a creature smaller than your thumb. The dread the cicada produces is not the dread of being hunted. It is the older, stranger dread of being overwhelmed, of standing inside something vast and alive and utterly beyond your control, and understanding all at once how little say you have in it. This is where the emergence begins. It is not where it ends. Turn a cicada nymph over and look at its front legs, and you are looking at a tool. Not a leg adapted for walking, not a leg for clinging, a leg built from the ground up for digging. The forelegs of a periodical nymph are thick, short, and powerful, ending in curved, blade-like extensions that work exactly like the blade of a shovel. They are heavily muscled, far stronger in proportion than anything the delicate adult will need, because the nymph's entire existence underground depends on them. For 17 years, these legs are how the creature moves through solid earth, loosening soil, hauling the body forward, carving the tunnels that keep it near the tree roots it feeds on. It is a body part that gives away the whole life history. An adult cicada, with its broad wings and slender legs, looks like a creature of the air, but the nymph it once was looked like a creature of the soil, pale, blunt, armored with those oversized digging arms held out in front like the bucket of an excavator. The shift between the two forms is so complete that the nymph and the adult barely seem to belong to the same animal. Watch a nymph dig, and the comparison to a machine becomes hard to avoid. The forelegs bite into the earth brace and pull the blade-like edges shearing through packed soil, the body following behind through the gap. It is slow, methodical, relentless, the same patient labor repeated across years that brings the creature from a fallen egg deep into the ground and eventually all the way back up to the light. The shovel arms are the first and last tool of its buried life. We heard the song fill the forest. Now look at the organ that makes it, because there is nothing else in nature quite like it. The timbal sits on each side of the male's abdomen, a region of the exoskeleton thinned and shaped into a curved plate, crossed by a series of stiff ribs. It is not a string to be plucked or a column of air to be blown across. It is a structure that makes sound by buckling. A powerful muscle anchored inside the body pulls on the timbal, and the ribbed plate snaps inward with a sharp click, the same physical principle as pressing the lid of a tin can until it pops. Then the muscle releases, the timbal springs back to its original shape with a second click, and the cycle is ready to repeat. What makes it a song rather than a series of taps is speed. The muscle fires with extraordinary rapidity, buckling and releasing the timbal hundreds of times every second, far faster than the eye could ever follow, and the individual clicks fuse into the continuous tone we hear. It is a fundamentally strange way to make sound. We make sound by pushing air through a flexible tube. Crickets make sound by rubbing body parts together. The cicada makes sound by deforming a piece of its own shell over and over at blistering speed using a muscle built for nothing else. And the precision is remarkable. By varying the rate and pattern of the buckling, a male can shape his song, the rhythm, the pulses, the rises and falls that distinguish his species from every other singing in the same trees. The timbal is not just a noisemaker. It is an instrument fine enough to carry a specific message snapped out one buckle at a time. A click is a small sound. To turn the timbal's clicking into a roar that crosses open fields, the cicada relies on what surrounds it, a body built largely as an empty box. In the singing male, much of the abdomen is hollow. Where you might expect dense tissue and organs packed tight, there is instead a large, air-filled space, a chamber whose entire purpose is to take the sound the timbals produce and make it bigger. This is resonance, the same principle that lets the hollow body of a guitar swell the faint vibration of a string into music that fills a room. The timbal supplies the vibration. The hollow abdomen amplifies it. The result is a body that is to a surprising degree mostly instrument. The male cicada sacrifices interior space another insect might fill with reserves or muscle to become a better speaker. Its anatomy is bent toward broadcasting. It is shaped to be heard. This is part of why people are startled to learn how the song works. The volume coming off a cicada seems impossible for something so small, and the secret is that the creature is in a sense more shell than substance. It has hollowed itself out to make room for sound. Tap the abdomen of a singing male, and you are tapping the wall of a drum. There is an elegance to the whole arrangement. The timbals generate the raw clicks. The hollow abdomen catches and magnifies them, and membranes and openings on the body help tune and release the sound outward, so that what begins as a muscle snapping a plate of shell ends as a tone audible a mile away. A small engine, a large echo chamber, and a body designed around the single goal of being impossible to ignore. Here is one of the strangest facts about how a cicada survives, and it reframes the entire 17-year wait. For all those years underground, the nymph feeds on one of the least nourishing substances a living thing can live on. Plants move fluid through two internal systems. One, the phloem, carries rich sugary sap, the good stuff dense with energy, which many sap-feeding insects target. The other, the xylem, carries water and dissolved minerals up from the roots, and it is thin, watery, and almost devoid of nutrition. The cicada nymph feeds on the xylem. It chooses, in effect, to drink the plant's water rather than its food. This is a baffling way to make a living. Xylem fluid is so dilute that an animal trying to grow on it faces a constant deficit. It must process enormous volumes just to extract a meager return. It is the nutritional equivalent of trying to survive on a diet of weak broth, sipped slowly for years on end. And yet this is precisely what the cicada does, and the choice shapes everything about it. Because xylem offers so little, growth is agonizingly slow. The nymph cannot rush. It cannot pack on size and develop quickly the way a well-fed insect can. It must take years, many years, to gather drop by thin drop the resources it needs to eventually become an adult. The 17-year cycle is not unrelated to this diet. A creature living on near-empty fluid simply cannot live fast. It is a portrait of extreme patience written into biology. Where other insects seize the richest food and grow in weeks, the cicada commits to the thinnest possible diet and stretches its development across decades, surviving slowly on almost nothing at all. To drink from the xylem, the nymph needs a way to reach it, and the way is a mouthpart unlike a chewing jaw or a biting mandible. It is a fine, hollow tube designed to pierce and to tap. The cicada's proboscis is a slender, straw-like structure that the nymph drives directly into the root of a tree, threading past the outer tissue until it reaches the xylem vessels carrying fluid up from below. Once it makes the connection, the nymph essentially plumbs itself into the tree's internal water supply, drawing the thin sap straight from the plant's own circulation. Picture it underground. A pale nymph anchored beside a root in the dark, its tube-like mouth sunk into the living wood, sipping slowly from the tree's plumbing. It does not move much. It does not need to. As long as it stays connected to a working root, the fluid comes to it, and the nymph holds its position, sometimes for years, feeding from the same source. This intimate dependence on roots explains a great deal about the cicada's hidden life. The nymph cannot wander freely. It must stay where the roots are, near the trees whose xylem keeps it alive. Its world is defined by that plumbing, the network of roots threading through the soil, each one a potential tap, each one a thin lifeline of fluid. And it is a quiet kind of parasitism, gentle enough that the tree generally survives it without much harm. A few nymphs drawing xylem from a mature root take little the tree cannot spare. Multiplied across a brood, the draw is larger, but even then the trees mostly endure. The cicada takes its slow drink, the tree keeps growing, and the strange arrangement holds for 17 years. Root and insect joined in the dark. We have looked at the red eyes from a distance in their unsettling thousands. Look at the head of a single cicada up close, and the visual system turns out to be stranger and more complete than 2 eyes suggest. The cicada has 5. The 2 large prominent eyes set wide on the sides of the head are compound eyes, each one built from many tiny lenses, packed together. The standard insect design, good at detecting motion and forming a broad mosaic picture of the world. These are the red ones, the eyes that catch the light and seem to stare. But between them, on the top of the head, sit 3 more eyes, small, simple, often overlooked, arranged in a little triangle. Instead, they are exquisitely sensitive to light and dark, to brightness and its changes. And biologists believe they help the cicada orient itself, to sense the position of the sky, to tell up from down, to register the shift between light and shadow as it flies. So the cicada navigates the world with a divided visual system. The 2 large compound eyes handle the detailed work of seeing shapes and movement. The 3 small, simple eyes handle the broad, fast business of tracking light itself. Together, they give the insect a fuller awareness of its surroundings than either could alone. It is a quietly alien arrangement. We are built around 2 eyes, and we tend to imagine other creatures the same way. The cicada carries a different solution on its head, a pair of mosaic eyes for the picture, and a trio of light sensors crowning the skull, all of them working at once. Look closely at that small triangle of extra eyes, and the familiar insect becomes again faintly strange. Of all the relics a cicada emergence leaves behind, the most haunting is also the most common. It clings to tree trunks and fence posts by the thousands, pale and brittle, and empty the discarded skin of the nymph, abandoned at the moment it became an adult. A cicada cannot grow inside a rigid shell, so to transform it must climb out of its own exoskeleton entirely. Anchored to a vertical surface, the nymph's hard outer skin splits along a seam down the back, and through that opening, the adult slowly hauls itself free, head first, then legs, then the crumpled wings, working its way out of the shell that held it. What it leaves behind is a perfect hollow replica of itself. The empty husk keeps the exact shape of the nymph, the legs, the digging arms, the head, the split down the back, where the adult emerged, but it is vacant now, a ghost in the literal sense, the form without the life. It stays clamped to the bark where it was shed, gripping with legs that no longer hold anything, sometimes for weeks after the insect that wore it has flown, mated, and died. Children collect them. They are dry and light and oddly durable, and they hold their shape so faithfully that the empty shell looks at a glance like a living cicada frozen in place. Only when you pick one up and feel how weightless it is, how hollow does the truth land, there is nothing inside. In a heavy emergence, these husks accumulate everywhere, layering the trees alongside the living insects until trunk and branch are studded with the cast-off skins of a transformation that happened all at once across a whole forest in the dark. Each one marks a single cicada's passage from its buried life into its brief life in the air, a molt left hanging like a held breath. The moment a cicada climbs free of its old shell, it is not yet the creature you picture. It is soft, pale, and crumpled, and its wings are not wings at all yet, but small, folded, useless pads pressed against its body. What happens next is one of the quiet marvels of the emergence. The freshly emerged adult pumps fluid into its wings. Through a network of veins running through the wing tissue, the cicada forces its own body fluid outward, and the crumpled pads slowly unfurl, expanding, smoothing, flattening into the broad, clear, veined wings that will carry it into the trees. It is a kind of hydraulic inflation, the wing taking its final shape not by growing but by being pumped full and pressed open from within. It happens slowly, and it must not be rushed. For the minutes, sometimes longer, that the wings are inflating and hardening, the cicada is utterly defenseless. It cannot fly. It can barely move. It clings to its perch pale and soft while its wings stretch to full size and its new exoskeleton gradually darkens and hardens around it. A cicada, caught in this stage, is an easy meal, which is one more reason the nymphs climb high and emerge under cover of night away from the worst of the daytime predators. Watch the process, and you see the insect assemble itself in real time. The body firms. The color deepens from ghostly white toward the adult's dark tones. And the wings drop by drop fill and flatten and gleam until at last they are ready, and the cicada, no longer soft, no longer pale, opens them for the first time and takes to the air. It has waited 17 years to enter, return to the puzzle of the diet because it deserves a fuller reckoning. A cicada nymph spends up to 17 years feeding on xylem fluid, a liquid so dilute it is barely food at all. And somehow, on that thin ration, it survives, grows, and assembles the body of an adult. How? The answer is a combination of patience, processing, and partnership. Patience, because the nymph simply does not try to grow quickly. It accepts a glacial pace of development that matches the meagerness of its food. Processing, because to extract enough from such dilute fluid, the nymph must take in and filter large volumes over time, wringing a slow trickle of usable resources from an enormous flow of watery sap. But the most remarkable part is the partnership. Living inside the cicada's body are specialized microbes, symbiotic bacteria passed from mother to offspring that the cicada cannot live without. Xylem fluid lacks key nutrients the insect needs, including certain essential building blocks it cannot make on its own. The microbes supply them. In the sealed chemistry of the cicada's body, these bacterial partners manufacture the missing pieces, turning an impossible diet into a survivable one. It is a collaboration written into the deepest level of the cicada's biology, an insect and its internal microbes bound together across evolutionary time, neither fully able to live without the other. The cicada provides the home and the raw fluid. The microbes provide the chemistry the fluid lacks. Without that hidden partnership, the 17-year wait would be impossible. No animal could build itself from xylem alone. The cicada manages it only because it does not live alone. It carries inside its own cells the collaborators that make its starvation diet enough. The thinnest diet imaginable, survived by never truly facing it alone. The adult cicada is a creature of open air and sunlit branches, but for almost its entire life, the cicada is a nymph, and the nymph's body is built for a completely different world, the wet, dark, crushing environment of packed soil. Everything about it is shaped to endure underground. The nymph's exoskeleton is tougher and more compact than the adult's, built to resist the constant abrasion of moving through earth. Its form is blunt and streamlined for pushing through soil rather than flying through air, And critically, it is adapted to cope with moisture, living for years in damp ground, often near water-carrying roots. The nymph must manage constant exposure to wet conditions that would ruin a more delicate body. There is none of the adult's fragility here. The winged adult is a brief, vulnerable thing, all thin membrane and exposed surface, built to last only weeks. The nymph is its opposite, durable armored low to its work, constructed to survive years in an environment with no light, little oxygen compared to the surface, and the perpetual pressure of surrounding earth. It is genuinely two animals in one life. The same individual that will one day inflate gossamer wings and sing in the canopy spends the overwhelming majority of its existence as a tough, pale, soil-adapted digger, a body you would never guess could become the creature it eventually does. The transformation between them, when it finally comes, is so total that it is easy to forget they are the same life. This is part of what makes the cicada so uncanny. The form we know, the loud, red-eyed, winged adult, is the brief exception. The true cicada, the one that exists for almost all of those 17 years, is the buried one. Armored, patient, built not to fly but to wait. For the cicada to emerge on schedule altogether, after exactly 17 years, it must somehow keep track of time. And one of the great, strange questions of its biology is how a creature buried in silent soil with no calendar and no sky manages to count the years at all. Part of the answer appears to lie in the tree itself. The nymph feeds on root xylem, and that fluid changes with the seasons. Each year, as the tree leafs out in spring and goes dormant in autumn, the chemistry and flow of its sap shift in a regular, repeating pattern. Researchers believe the cicada nymph can detect these annual cycles in the fluid it drinks effectively, reading the tree's own rhythm as a clock and tallying the passing years by the seasonal pulse of the sap it feeds on. In a striking experiment, scientists manipulated the trees that cicada nymphs were feeding on, tricking the plants into completing 2 growth cycles in a single year. The nymphs feeding on those trees emerged a year early, as though they had counted 2 years instead of 1. It was strong evidence that the cicada is not running on some purely internal calendar, but is at least partly reading time off the tree through the seasonal signal in the sap. This is a profound kind of timekeeping. The cicada outsources part of its clock to the forest. It does not need to track the years on its own. It lets the tree's annual rhythm do the counting, registering each cycle of dormancy and growth as one more tick toward the year it will rise. But this only deepens the mystery, rather than closing it. Counting to 17 and knowing when 17 has arrived precisely enough that millions emerge together requires more than just sensing the seasons. Exactly how the nymph keeps that count and how it holds it so accurately across so long a span remains something scientists are still working to understand. The difference between a male and a female cicada is not just behavioral. It is structural, written into the very contents of their bodies. Open them up, and they are built around opposite purposes. The male, as we have seen, is hollow. Much of his abdomen is given over to empty, air-filled space, the resonating chamber that turns his timbrels' clicks into a chorus loud enough to cross a field. His body is organized around sound, around being heard, around broadcasting his presence to females across the noise of thousands of rivals. He is in a real sense built to sing. The female is the opposite. Where the male is hollow, she is full, her abdomen packed with eggs, hundreds of them, the next generation waiting inside her. Her body is organized around carrying and placing those eggs, and at the tip of her abdomen she bears a specialized cutting tool, the ovipositor, built to slit into twigs and deposit her eggs inside the wood. It is a clean division of labor stamped into anatomy. The male's task is to be found, to advertise loudly and continuously until a female chooses him. The female's task is to produce and place the eggs that will carry the brood into the next cycle. He is a hollow instrument of sound. She is a full vessel of eggs. Neither is built to do the other's job, and both are essential to the single project the whole emergence serves. The deafening chorus, the frantic mating, the brief weeks of adult life, all of it exists to get the male's song to reach the female and the female's eggs into the trees. 2 bodies built around 2 opposite interiors meeting for a few short weeks to launch the next 17-year wait. There is a brief window right after a cicada climbs from its shell, when it does not look like a cicada at all. For a short time it is ghost white and soft-bodied, its new exoskeleton not yet hardened, its color not yet arrived. Biologists call this the tenoral stage, and it is the most vulnerable moment of the insect's entire life above ground. A tenoral cicada is pale, sometimes almost luminous white, sometimes tinged with the faintest green or cream, and it is soft to the touch, its shell still pliable, not yet set into the firm armor of the mature adult. Its wings may still be inflating or freshly hardened. It cannot fly well, if at all. It can barely defend itself. It simply clings to its perch and waits for its body to finish becoming what it will be. In those hours, the cicada is at the mercy of everything. A bird, a raccoon, an ant, even a careless gust, anything could end it before it ever takes wing. This is the price of the molt to become an adult. The cicada must pass through a stage where it is utterly exposed, soft as fresh dough, unable to escape, waiting in the open for its armor to harden. It is also briefly, strangely beautiful. A freshly emerged tenoral cicada, pale and gleaming against dark bark in the night, has an almost unreal quality, a soft, luminous thing that looks more like something sculpted than something alive. Photographers prize the image, but the beauty is fleeting, and so is the danger. Within hours the shell darkens and firms, the color deepens, the wings set, and the soft white ghost becomes the hard, dark, red-eyed adult ready for the trees. The tenoral stage is the seam between the cicada's two lives, the last soft moment between the buried digger and the winged singer. A cicada has no lungs. No insect does. And this raises a question that becomes especially pointed for a creature that spends 17 years buried in soil. How does it breathe? Down there in the dark, surrounded by earth. Insects breathe through a system of tubes. Along the sides of the body run small openings called spiracles, and from each spiracle a branching network of fine tubes. The tracheae threads inward, carrying air directly to the tissues that need it. There is no central pump, no lungs drawing breath. Instead, air moves through this network of tubes to reach the cells throughout the body, delivering oxygen straight to where it is used. For the buried nymph, this system has to keep working in conditions that would seem to forbid it. The cicada lives in soil, often damp soil where air is limited and water is a constant threat to the delicate breathing tubes. The spiracles must take in enough air from the spaces between soil particles to supply the body. While keeping soil and water out of the system a balance, the nymph maintains for years on end, in an environment far less forgiving than open air. It is one more way the nymph is quietly engineered for its buried world. The same basic breathing apparatus that serves a butterfly in open sunlight serves the cicada nymph in the crushing dark of packed earth, adapted in the nymph's case to draw breath from the thin air trapped in soil year after year, without flooding or clogging. When the adult finally emerges into open air, breathing becomes easy, abundant oxygen, no soil, no damp. But for almost the whole of its life, the cicada manages the harder task, pulling enough air through tiny side openings to stay alive while buried in ground that offers very little of it. Among everything strange about the cicada, this may be the strangest and the most disturbing. There is a fungus that infects periodical cicadas, takes over their bodies, and turns them into something out of a nightmare. Its name is Mesospora. The infection begins underground, or at emergence, and as it develops, the fungus does something grotesque. It consumes the back portion of the cicada's body from the inside, replacing the insect's abdomen with a chalky plug of fungal spores. The cicada's rear end essentially falls away, leaving the creature with its hindquarters hollowed out and packed with the pale, crumbling mass of the fungus that is eating it. And here is the part that crosses into the uncanny. The infected cicada does not stop. It keeps moving, keeps flying, keeps trying to mate, even as its body falls apart and its abdomen is gone. The fungus appears to manipulate the insect's behavior, driving it to attempt mating with as many partners as possible, because every such attempt spreads the spores to new hosts. Researchers have found that the fungus produces compounds that may alter the cicada's behavior, keeping the doomed insect active and hypersexual, an unwitting agent of its own infection spread. Scientists have described infected males that even mimic the wing flick signals of females, luring in other males and spreading the fungus to them as well. The cicada in effect becomes a flying dispenser of spores. Its behavior commandeered, its body consumed, kept going just long enough to infect as many others as it can before it dies. It is a genuinely unsettling piece of biology, a fungus that hollows out a living creature and hijacks its drives, turning the cicada's own urge to reproduce into the engine of the fungus's spread. The infected cicada flies on, missing half its body, driven by something that is no longer entirely itself. We have followed the cicada's tube-like proboscis into the tree root. Look closer at that mouthpart itself, because it is a precision instrument and it tells you everything about how the cicada makes its living. The cicada belongs to a group of insects whose mouthparts are built not for chewing but for piercing and sucking. Instead of jaws that bite and grind, the cicada has a set of fine, needle-like structures bundled together into a slender shaft. Within that shaft run separate channels, one to inject saliva, another to draw fluid up so that the insect can simultaneously pierce, treat, and drink from the plant tissue it taps. To reach the xylem deep in a root, these mouthparts must penetrate living wood and thread precisely into the narrow vessels carrying fluid. This is delicate work. The cicada is not hacking into the root. It is inserting an exquisitely fine probe, finding the exact channel where the thin sap flows and locking on. Miss and there is nothing to drink. Hit, and the tree's own circulation does the rest, fluid, rising through the cicada's straw of a mouth from the plant's plumbing. It is the same fundamental equipment, scaled and shaped, that lets other insects in the cicada's broader family pierce plants and drink their fluids. In the cicada, it is tuned for a life spent tapping roots in the dark, for finding again and again across the years the precise vessel that will keep the nymph alive. There is an elegance to it that sits oddly against the brute patience of the cicada's life. The waiting is crude, years of slow growth on thin fluid, but the instrument that makes the waiting possible is fine, precise, surgical, a needle of a mouth threading into the hidden plumbing of a tree, drawing life from a channel no thicker than a hair. The cicada's song depends on muscle, and muscle depends on warmth. A cicada is cold-blooded. It cannot generate its own body heat the way a mammal does, and this fact governs when and how it can sing and even fly. To drive the timbal at the blistering speed, its song requires the male's sound muscles must be warm enough to fire rapidly. When the air is cool, the cicada is sluggish, its muscles slow, its song weak or absent. So before the chorus can build, the cicadas must warm themselves, and the way they do it is to bask. They climb into the sun, spread themselves to the light, and let the warmth soak into their bodies until their muscles reach the temperature that lets them perform. This is why the great choruses swell with the heat of the day. In the cool of early morning, the forest is relatively quiet. As the sun climbs and the air warms and the cicadas absorb that heat, the singing intensifies, building toward its peak in the warm hours, then easing again as the day cools toward evening. The roar follows the sun. It also shapes flight. A cool cicada is a clumsy, reluctant flyer. A sun-warmed one is far more capable. The insect's entire activity level rises and falls with the temperature of its surroundings because it has no internal furnace of its own, only the borrowed heat of the day. There is something fitting in this. The creature that spent 17 years in the cool, constant dark of the soil emerges into a life governed entirely by the sun's warmth, basking to find the heat to sing, falling quiet when the heat withdraws. After all those years, underground temperature is no longer just comfort. It is the very thing that switches the cicada on, the warmth that turns a silent insect into a singing one. Pick up a cast-off cicada shell, and the first thing you notice is how it feels. Dry, light, crisp. It weighs almost nothing, and it has a delicate, papery rigidity like a thing made of stiff parchment shaped into the form of an insect. This crispness comes from what the shell is, and what it no longer contains. The discarded husk is pure exoskeleton. The hardened outer cuticle the nymph wore now, emptied of all the living tissue that filled it. No muscle, no fluid, no organs. Just the shaped outer shell dried in the open air, holding the exact form of the creature that shed it, but none of its substance. The result is something oddly satisfying and oddly eerie to handle. The shell keeps every detail, the segmented legs, the curved digging arms, the domed head, the split down the back with perfect fidelity, yet it is so light and brittle that a careless squeeze will crush it to flakes. It crunches between the fingers the way it crunches underfoot, a small dry collapse, the form giving way to nothing. This is why the shells are at once a children's treasure and a faintly unsettling object. They look complete. They hold the shape of a living thing so well that the eye keeps insisting something is there. But the crispness gives it away, that papery, weightless rigidity that no living creature has, the texture of a husk and nothing more. Across an emergence, these crisp shells number in the millions, drying on tree trunks and fence posts and the undersides of leaves, each one a faithful hollow cast of a cicada that has moved on. Crisp, empty, and exact, the shed armor of a transformation left behind to crumble back into the forest floor. For 17 years, the cicada nymph lives in a world without light, where the eyes that will one day matter so much are nearly useless. To sense its surroundings underground, it relies on other channels, and one of the most important is touch, transmitted through fine sensory bristles attuned to vibration. A cicada's body, like that of many insects, is studded with tiny sensory hairs and bristles that respond to physical disturbance, to vibration, to contact, to the subtle tremors that travel through the medium around it. For the buried nymph, this is a vital sense. In the dark soil, it cannot see what is near, but it can feel the vibration of movement, the tremor of disturbance carried through the earth and the roots it clings to. This sensitivity may help the nymph in several ways. It can register disturbances in its environment, perhaps sensing the activity of other nymphs nearby. And as the emergence approaches, vibration may even play a role in the extraordinary synchrony of it all. The possibility that nymphs, feeling one another's presence and movement through the soil, help coordinate the timing of their rise. It is a different way of knowing the world than we are built for. We lead with our eyes. The buried nymph leads with touch, reading the tremors of its dark surroundings through bristles too fine to see, building a picture of a world it cannot look at. And it fits the cicada's strange double life. The creature that will spend its final weeks in a riot of sound and light and sight spends almost all of its existence in silence and blackness, feeling its way, sensing the soil, not by looking but by the faint vibrations that reach it. Through the earth, a patient, blind awareness sustained across nearly 2 decades underground. Step back from all the strange anatomy, the shovel arms, the buckling timbal, the hollow body, the needle mouth, the soil-tough shell, and a single theme runs through every piece of it. The cicada is not built to live fast, it is built to wait. Almost everything about the creature is shaped toward endurance over time, rather than intensity in the moment. The thin diet that forces slow growth. The armored patient nymph body, built to survive years in the soil. The diapause-like restraint that holds millions of insects underground for 17 years without breaking ranks. This is not the design of an animal that seizes life and burns through it. It is the design of an animal that holds on and holds on and holds on, and then at the very end spends everything at once. Most insects live by the opposite logic. They develop quickly, reproduce fast, and many die within a single season, packing their entire existence into weeks. It pours the overwhelming majority of its life into a long, slow, buried waiting, and compresses all its living, the singing, the flying, the mating, into a brief final burst of a few short weeks. It is a strange bet to make in evolutionary terms, and a strange shape for a life to take. 17 years of patience for 1 month of flight, a body engineered down to its diet and its breathing, and its very pace of growth for the long game of waiting rather than the short game of living fast. And it works. This patient design has carried the cicada through immense stretches of time, kept it alive where faster strategies might have failed, and produced one of the most extraordinary timekeeping feats in all of nature. The cicada's whole uncanny body is the answer to a single question: how do you wait alive for 17 years? And every strange part of it is a piece of that answer. That waiting and the astonishing precision behind it is where the story turns next. Here is where the cicada stops being merely strange and becomes, to anyone who looks closely, astonishing. Periodical cicadas do not emerge at random intervals, or roughly every so often. They emerge after a precise, fixed number of years, and the numbers they have chosen are 13 and 17. In the eastern United States, periodical cicadas come in 2 kinds. Some broods run on a 17-year cycle, spending exactly 17 years underground before they rise. Others run on a 13-year cycle, emerging after exactly 13. Not 12, not 14, not 16 or 18. 13 and 17 held to with a fidelity that is hard to believe a soil-bound insect could manage. Sit with the precision of that for a moment. A creature buried in the dark, feeding on root sap with no calendar and no sky, counts the passing years and counts them so accurately that after 17 of them, millions of individuals across an entire region rise within days of one another. The error rate is tiny. The vast majority hold the count exactly emerging in the correct year, having tracked the better part of 2 decades from underground. There is nothing else quite like it among insects. Plenty of creatures have annual cycles tied to a single turning of the seasons. A handful stretch their development across a few years, but a precise multi-year cycle locked to a specific number 13 or 17 emerging in synchronized mass, after all that time, is something the periodical cicadas have made their own. And the choice of those particular numbers is not arbitrary. 13 and 17 are not random lengths the cicada happen to settle on. They are, as we are about to see, exactly the numbers a creature would choose if it wanted to outwit the mathematics of being eaten, a strategy hidden in the properties of the numbers themselves. Look again at the 2 cycle lengths, 13 and 17, and notice what they have in common. Both are prime numbers. Each can be divided evenly only by 1 and by itself. And biologists have come to believe this is no coincidence at all, but the very heart of the cicada's strategy. A prime-numbered life cycle has a remarkable mathematical property it shares, common factors with very few other numbers. A cycle of 17 years will only line up with a predator or competitor cycle at long intervals, because 17 being prime refuses to divide neatly against most other periods. A creature emerging every 17 years is exceptionally hard for any shorter, regular cycle to track or synchronize with. Compare this to a cicada that emerged every 12 years. 12 is rich in factors. It divides evenly by 2, 3, 4, and 6. A predator with a 2-year cycle, a 3-year cycle, a 4-year cycle, or a 6-year cycle would all periodically line up with that 12-year emergence, their booms coinciding with the cicada's arrival. The cicada would keep meeting predators at their peak. By choosing a prime 13 or 17, the cicada slips between these traps. Its emergence rarely coincides with the population peaks of predators or the cycles of competitors, because a prime number simply does not align with most other numbers except at very long intervals. The cicada arrives again and again out of step with whatever might be waiting to exploit it. It is a genuinely beautiful piece of natural mathematics, a survival strategy encoded not in teeth or venom or speed, but in the abstract properties of prime numbers. The cicada has in effect stumbled through evolution onto a theorem that to be hard to predict and hard to track, you should run your life on a prime. And it has done so not by understanding the math, but by being shaped across vast time by the simple fact that the cicadas running on primes survived and the others did not. We saw predator satiation from the inside, the gorged dog, the stuffed birds, the predators eating themselves sick and still failing to make a dent. Now see it as the deliberate evolutionary logic it is working hand in hand with the prime number timing to keep the cicada alive. The strategy has 2 halves, and they fit together with real elegance. The first half is overwhelming. Number emerge all at once in such staggering quantities that no combination of predators could ever eat them all, guaranteeing that the vast majority survive simply because there is far too much food to finish. We have seen this. The second half is the prime-numbered timing, which ensures that when the cicadas do emerge, they catch their predators unprepared, out of sync, their own numbers not built up in anticipation. Together, these 2 halves form a defense that is nearly airtight. If predators could anticipate the emergence, they might build up their populations in advance, swelling their numbers in the years before the cicadas arrived, ready to feast. The long prime cycle prevents this. There is no way for a predator to maintain elevated numbers across 13 or 17 lean years, waiting for a single feast, and the prime interval keeps the emergence from lining up with the predator's own cycles. So when the cicadas finally rise, they meet a predator population that is no larger than usual, utterly incapable of consuming the flood. This is why the strategy is called predator satiation. The cicadas do not try to avoid being eaten. They embrace it. They offer themselves up in such numbers that being eaten becomes harmless to the population as a whole. Millions die in the jaws of birds and mammals and fish. It does not matter. The satiation is total, the predators fill and quit, and the overwhelming majority of cicadas are left untouched. It is defense by generosity in a sense, survival through deliberate, calculated excess. And paired with the prime-numbered clock, it has proven one of the most durable survival strategies any animal has ever evolved. We touched on the cicada's strange clock earlier, the way it seems to read time off the tree. In the context of that precise prime-numbered cycle, the mechanism deserves a closer look because the accuracy required is staggering. The leading idea is that the nymph counts years by detecting the annual rhythm of the tree it feeds on. As a deciduous tree moves through its yearly cycle, leafing out in spring, growing through summer, going dormant in winter, the composition and flow of its xylem sap change in regular seasonal ways. The nymph, plugged into the root and drinking that sap year-round, experiences these changes as a repeating annual signal. Each cycle of the tree is in effect one tick of the cicada's clock. The experiment that supports this remains one of the most elegant in the field. By inducing host trees to leaf out twice in a single year to run 2 growth cycles where there should have been 1, researchers found that the cicadas feeding on those trees emerged a year early. The nymphs had counted the extra cycle as an extra year. They were not running on a fixed internal timer, immune to outside input. They were reading the tree, and the doubled signal fooled them into thinking more time had passed than truly had. But registering the annual signal is only part of the puzzle, and arguably the easier part. The harder question is how the nymph tallies those signals accurately all the way to 13 or 17 and knows when the count is complete. Sensing 1 year is one thing. Holding a running count across nearly 2 decades, precisely enough that millions finish the count in the same year, is something far more remarkable and far less understood. So the cicada appears to keep time through a partnership with the forest, borrowing the tree's seasonal rhythm as the beat of its own clock, while the deeper machinery that counts those beats to a prime number remains in important ways, a mystery still being unraveled. Of all the cicada's astonishing feats, the synchrony may be the most breathtaking. It is not merely that the cicadas emerge after the right number of years. It is that across an entire region, millions upon millions of them emerge together, within days of one another, sometimes within a single window of nights. Consider what this requires. These are individual insects scattered across a vast area, buried separately in the soil, at varying depths, feeding on different trees, experiencing slightly different local conditions. And yet after 17 years of independent underground life, they converge on the same brief moment to rise, the whole brood coordinated, surfacing as one. This synchrony is the engine that makes everything else work. Predator satiation depends on it. Absolutely. If the cicadas trickled out over weeks or months, predators could pick them off steadily as they came, and the overwhelming number defense would collapse. It is only because they emerge all at once in a single concentrated pulse that they swamp every predator and guarantee the survival of the majority. The synchrony is not a curiosity layered on top of the strategy. It is the strategy. How they achieve it is a combination of factors. The shared clock reading the same seasonal signals off the trees brings the whole brood to readiness in the same year. Then a common environmental trigger, the warming of the soil to a specific temperature, releases them together like a starting gun fired across the entire region at once. Vibration and the sensing of one another underground may help fine-tune the final timing. The result is one of the most precisely coordinated mass events in the living world. Not dozens, not thousands, but millions of separate lives, each having waited the same 17 years in its own patch of dark soil, all arriving at the surface, together a synchrony so tight it is hard to believe it emerges from millions of insects acting individually, with no leader and no signal but the ones written into their biology and the warming ground. The years-long count brings the brood to readiness. But something has to fire the starting gun, some final shared signal that tells millions of nymphs that the moment has arrived tonight altogether. That signal is the temperature of the soil. Periodical cicadas wait in their final readiness for the ground around them to reach a specific warmth. The threshold is remarkably consistent when the soil, about 8 inches down, warms to roughly 64 degrees Fahrenheit, the nymphs begin to move toward the surface. It is the last key turning in the lock, the count of years complete. And now the soil itself confirming that spring has truly arrived and the time to rise is here. This is an elegant final check. The temperature trigger ensures the cicadas do not emerge too early in a deceptively warm spell, or while the ground is still cold and hostile. The soil at that depth changes temperature, slowly and steadily, smoothing out brief fluctuations, so that when it finally reaches the threshold, it is a reliable signal that the season is genuinely right. The cicadas have counted the years. The soil temperature tells them the day. And because the whole region's soil warms to that threshold around the same time, the temperature trigger reinforces the synchrony. Millions of nymphs, all waiting on the same cue, all feeling the same ground, warm beneath the same spring sun, surge upward together when the threshold is crossed. A warm rain often accompanies the emergence, the combination of warmth and moisture seeming to release them in a flood. It is the meeting point of the cicada's long internal clock and its immediate environment. Years of patient counting resolved at last by a single physical reading of the world. Means now. After 17 years, the final command to rise comes not from within but from the warmth of the earth itself. Not all periodical cicadas emerge in the same year. Across the eastern United States, they are divided into distinct populations, each on its own schedule, each emerging in its own year and its own territory. Scientists call these populations broods, and the map of them is one of the most fascinating features of the whole phenomenon. Each brood is a group of cicadas that emerges together in the same year across a defined geographic range. They are numbered by long convention using Roman numerals, and each has its own emergence year and its own map of where it appears. One brood might blanket parts of several states in a given year, another on a different cycle or offset by years, covers a different region in a different year. A person living in the East might experience one brood in their area, while a region a few states away lives on the schedule of an entirely different one. This means that periodical cicada emergences, while rare in any one place, happen somewhere in the eastern United States, far more often than every 17 years. Because the broods are staggered different populations emerging in different years, there is almost always some brood coming up somewhere. The 17-year wait is local. Zoom out to the whole map, and emergences are a near-annual feature, just rotating through different regions. The broods are remarkably stable in their territories, and their timing returning to the same areas year after counted, year cycle after cycle, with a fidelity that has allowed scientists to map them with real precision. Researchers can predict, often years or decades in advance, which brood will emerge where and when, a forecast made possible only by the cicada's extraordinary reliability. It is a vast, slow, interlocking clockwork spread across half a continent, dozens of distinct populations, each keeping its own count, each tied to its own ground, all running on the same prime-numbered principles, but offset from one to another in time and space, a living calendar written across the eastern forests. We have seen why a prime cycle is hard for predators to track. Sit with the mathematics a little longer, because the depth of the advantage is worth appreciating fully. It is a defense that compounds across time in a way no physical weapon could. Imagine a predator whose own population rises and falls on a cycle of a few years, a common enough pattern in nature where booms and busts repeat at regular intervals. If the cicada's emergence period shared a factor with that predator cycle, the two would periodically synchronize. Every so often the predator's population peak would land exactly on a cicada emergence, and the cicadas would meet a swollen, hungry predator population precisely when they were most vulnerable. A prime emergence period makes such alignment exceedingly rare, because 17 shares no factors with most smaller numbers. A 17-year cicada cycle will only coincide with, say, a 2-year predator cycle, or a 3-year one, or a 5-year one at very long intervals. The alignment pushed out to distant, infrequent points where the cycles finally come back into phase. For most of the cicada's emergences, it arrives out of step with the predator's peak slipping past, while the predator's numbers are average or low. The same logic protects against competing broods. If two different cicada populations ran on cycles that shared factors, they would periodically emerge in the same year, flooding the same area, competing and potentially interbreeding in ways that could blur their carefully maintained timing. Prime cycles keep them apart, their coincidences pushed to rare intervals far in the future. It is a defense that exists purely in the realm of number and time. The cicada cannot fight, cannot flee effectively, cannot hide once it emerges. What it can do is arrive on a schedule so mathematically slippery that almost nothing can reliably wait for it, a creature that has turned the abstract properties of primes into a shield against the timing of the living world around it. The cicada's timing is astonishingly precise, but it is not perfect, and the imperfections are themselves revealing. In most emergencies, a small number of cicadas break ranks, appearing years before or after the main brood. Scientists call them stragglers, and they are a window into how the whole system works, and perhaps how it changes. Stragglers typically emerge off-cycle by a set amount, often 4 years early or 4 years late, a pattern that reflects the underlying mathematics of the cicada's development and the way its life cycle can shift in whole number jumps. A 17-year brood might produce stragglers that come up after 13 years. A 13-year brood stragglers that wait 17. The offset is rarely random, it tends to follow these regular, meaningful intervals tied to the cicada's biology. Most stragglers are doomed. Emerging off-schedule away from the protective flood of their brood, they lose the entire advantage of predator satiation. A handful of cicadas appearing in a year when the rest of their kind remains underground are easy, isolated targets picked off by predators without the safety of overwhelming number. For the individual straggler, breaking the count is usually fatal. But stragglers may matter enormously over long stretches of time. Some scientists believe that if enough stragglers emerge in the same off-year and find one another and breed, they could in principle establish a new brood or even seed a shift from one cycle length to another. The 4-year offsets that stragglers so often show may be the very mechanism by which across deep time, cicada populations have switched between 13 and 17-year cycles, and by which new broods have arisen. So the imperfection in the cicada's timing is not just noise. It may be a source of evolutionary flexibility, a small, costly stream of rule breakers that mostly die, but that occasionally across the long reach of time redraw the map of broods and reset the great clock itself. The cicada's prime-numbered timing does more than dodge predators. It also keeps the different cycles, the 13-year and the 17-year, from blurring into one another, preserving the distinct populations across enormous spans of time. And the mechanism, once again, is hidden in the numbers. When two cycles share factors, they synchronize often, and frequent synchrony between cicada populations would create frequent opportunities for them to emerge together, meet, and interbreed. Such interbreeding could be disastrous for the precision of the system. Hybrid offspring with intermediate or scrambled timing would lack the tight synchrony that makes predator satiation work, and might emerge off-cycle, isolated and vulnerable, their carefully tuned clock broken. Prime cycles minimize these dangerous meetings. 13 and 17, both prime, share no common factors except one. And as a result, a 13-year brood and a 17-year brood emerging in the same place will only coincide once every 221 years, the product of the two primes. For more than 2 centuries at a stretch, the two cycles stay out of each other's way, emerging in different years, never meeting, never mixing. This is the cicada's mathematics, protecting its own integrity. By running on primes, the different cycles wall themselves off from one another in time, coinciding so rarely that interbreeding between them is vanishingly uncommon. Each cycle keeps its own tight synchrony intact, generation after generation. The primes acting as a kind of temporal isolation that no physical barrier could provide. It is a quietly profound example of how deeply the cicada's survival is bound up with number. The same prime cycles that hide it from predators also preserve the distinctness of its broods, keeping 13 and 17 pure across the centuries. The cicada's clock is not just a timer for emergence. It is a mathematical structure that holds the entire system together, predator defense and population integrity alike, written into the same 2 prime numbers. The deafening roar of an emergence is not random noise. It is organized strategically, even architecturally, and the structure of it reveals how the whole frantic business of finding a mate actually works. Male cicadas do not simply sing wherever they happen to land. They gather. They congregate in particular trees and particular patches of the canopy, clustering together to sing in dense concentrations that biologists call chorus centers. In these aggregations, hundreds or thousands of males sing together, and the combined volume is far greater than any individual could produce, a concentrated beacon of sound that carries across the forest. There is real strategy in this gathering. A lone male singing by himself is a faint signal easily lost, but a chorus center with its massed voices becomes a powerful attractant, drawing females from across a wide area toward the sound. By singing together, the males create a signal far louder and more far-reaching than the sum of their solo efforts and the females following that signal, to arrive at exactly the place where the greatest concentration of potential mates awaits. It is a cooperative arrangement built on top of fierce competition. The males benefit collectively from the chorus center's power to draw females in. Yet within that crowd, each male competes intensely with all the others to be the one a given female chooses. They cooperate to attract, then compete to win, singing together to summon the females, then vying individually for them once they arrive. The chorus centers shift and form across the emergence, the males clustering in favorable spots, the great walls of sound rising from these concentrated gatherings. What sounds from a distance like undifferentiated roar is in fact a structured landscape of singing aggregations, beacons of sound strategically massed, each one an arena where the central drama of the cicada's brief adult life plays out. Within a single emergence, there is often more than one species of periodical cicada singing at once. To us, the result is a single overwhelming roar. But to the cicadas, that roar is sorted into distinct channels because each species sings its own particular song, and those songs keep the species from interbreeding. Different periodical cicada species produce different calls, distinct in rhythm, pitch pattern, and structure. One species might produce a steady droning buzz, another a series of pulsing phrases, another a rhythm of ticks and tones all its own. These differences are not incidental. They are the cicada's way of recognizing their own kind amid the chaos, allowing a female to pick out and respond to the song of a male of her own species while ignoring the calls of others singing in the very same trees. This acoustic signature is a crucial barrier against hybridization. Where multiple species emerge together, song is what keeps their reproduction separate. A female is tuned to respond to the specific call of her own species. She orients toward it, finds males producing it, and mates within her kind. The songs of other species, however loud, do not trigger her response. The roar may be shared, but the meaningful signal within it is species-specific, and each cicada hears only its own. It is a remarkable feat of communication, carried out in the midst of staggering noise. In a chorus loud enough to drown a human voice, dense with multiple species all singing at once, a female cicada can still single out the call of her own kind and follow it to the right mate. The song is not just an attractant, it is a password, a species-specific signal that sorts the deafening confusion of the emergence into separate conversations, keeping each species' lineage distinct even as they all sing together in the same loud trees. The great chorus is the long-range advertisement, the beacon that draws females toward the singing males. But when a female actually arrives near a male, the communication shifts into something more intimate and more precise, a back-and-forth exchange, a courtship conducted in clicks. Once a female is close, the interaction becomes a duet. The male sings, and the female, if she is receptive, responds not with a song of her own, but typically with a sharp flick of her wings that produces a faint click. The male hears or senses this response and adjusts, often modulating his song, moving closer and waiting for her to signal again. The exchange continues, call and response. The male's song met by the female's clicks, the two closing the distance between them, step by step through this signaling dialogue. This is a far finer form of communication than the broadcast chorus. The chorus is a shout to the whole forest. The courtship exchange is a conversation between two individuals, a precise back and forth that confirms at close range that both are of the right species and that the female is willing. The timing of her response and its relationship to his song carries information, a coded exchange that guides the male to her and signals her receptiveness. It transforms our picture of the emergence's noise. From a distance, it is undifferentiated, raw. Up close, it resolves into countless individual courtships, each one a delicate duet of song and wing-click males, and females finding one another and confirming their match through this intimate signaling. Beneath the overwhelming wall of sound, the forest is full of these quiet, precise conversations, 2 cicadas at a time, clicking back and forth, negotiating the single most important moment of their brief lives above ground. That faint click the female makes in answer to the male's song is worth pausing on because the mechanism is so different from how the male produces his sound and so elegantly simple. The male sings with his specialized timbals, the buckling organs built for the purpose. The female has no such organs. She does not sing. Instead, she communicates with a flick of her wings, a quick, precise movement that produces a soft, snapping click timed to the male's song. It is a different instrument entirely, not a dedicated sound-producing organ, but the ordinary wings, flicked at just the right instant to make a meaningful sound. The timing is everything. The female's wing flick must come at a specific point in relation to the male's call, a precise interval after a particular phrase of his song for it to register as a proper response. Get the timing right, and the male recognizes the signal, responds, and moves toward her. This temporal precision is part of how the species keeps its courtship distinct. The exact timing of the female's reply, keyed to the male's species-specific song, helps ensure that only cicadas of the same kind successfully complete the exchange. Researchers have learned to exploit this. By snapping their fingers or clicking at exactly the right moment in a male's song, scientists can sometimes fool a male cicada into responding as though to a receptive female, luring him in, confirming just how much of the courtship rides on that precisely timed click. The male, hearing the right sound at the right instant, treats it as the genuine signal and approaches. It is a beautifully economical piece of communication. The female needs no special organ, no song of her own. She needs only her wings and exquisite timing, a flick delivered at precisely the right moment, turning ordinary wings into a signal as meaningful in its way as the male's elaborate song. The cicada chorus is not a constant, unchanging drone. It has a daily rhythm, a rise and fall across the hours that follows the sun and the warmth, and that the males coordinate among themselves in patterns far more structured than random noise. We have seen that cicadas need warmth to sing, and so the chorus swells with the heat of the day and eases as it cools. But layered on top of this temperature-driven pattern are finer rhythms of coordination. Within the chorus centers, males do not sing in pure chaos. Their singing rises and falls in waves, surges of sound passing through the aggregation as males stimulate one another, fall into loose synchrony, and build collective bursts of song that swell and subside. Different species, too, may favor different times of day, partitioning the daylight hours among themselves. Some sing most intensely in the heat of midday, others prefer the softer light of morning or the approach of evening. This timing helps separate the species' signals in time as well as in sound, giving each its own window in which its particular song dominates the chorus. The result is a soundscape with structure across the whole day, building from the relative quiet of cool early morning, swelling through the warm hours into the full roar of peak chorus, surging in waves as the males stimulate one another, then easing again toward evening as the air cools and the cicadas fall gradually silent. Across the weeks of the emergence, this daily cycle repeats, the forest breathing its great sound in and out with the rhythm of warmth and light. It is one more layer of order beneath the apparent chaos. What sounds like a formless wall of noise is in fact a coordinated rhythmic phenomenon timed to the sun, structured by the interplay of singing males, partitioned among the species, rising and falling in a daily pattern as reliable as the heat that drives it. For all that we have learned about the cicada's timing, the tree signal counting the temperature trigger, the prime-numbered cycles, the deepest question remains genuinely unsolved. Exactly how the cicada counts to 13 or 17 and holds that count so precisely across so many years is something scientists still debate. The evidence that nymphs read the tree's annual cycles is strong, and the experiment that pushed cicadas to emerge a year early by doubling the tree's growth cycles is compelling. But knowing that the cicada senses the passing years does not explain how it tallies them. What is the mechanism that registers each year, stores the running total, and recognizes when the count has reached exactly 17? Where in this small insect is the counter kept? Researchers do not fully know. Several possibilities are debated. Perhaps there is a molecular or physiological process that changes incrementally with each year accumulating until it crosses a threshold. Perhaps developmental stages are gated by the count, the nymph passing through its phases on a schedule locked to the years it has tracked. Perhaps the mechanism involves the symbiotic relationship with the host tree more deeply than we yet understand. Scientists continue to investigate, and the honest state of the science is that the precise machinery of the cicada's clock remains in important respects a mystery. There is something fitting, even humbling, in this. The cicada performs one of the most extraordinary feats of biological timekeeping known, and we, with all our instruments and experiments, still cannot fully explain how a soil-bound insect counts the better part of 2 decades and gets it right. The creature keeps perfect time by a method we have not entirely deciphered. It is a reminder that awe and mystery are not opposites here. The more precisely we measure what the cicada does, the more remarkable the unexplained mechanism behind it becomes, a clock of stunning accuracy ticking inside a creature whose timekeeping we can observe in awe but cannot yet fully read. One idea about how the cicada keeps its count touches on the stages of its own development, the series of molts the nymph passes through underground, and the possibility that the count is tied to these developmental steps rather than to a simple year tally alone. A cicada nymph does not grow continuously. It grows in stages, passing through a series of instars, each separated by a molt in which it sheds its old skin and enters a larger form. There are 5 of these nymphal stages over the long underground life. Some researchers have explored whether the progression through these stages is itself part of how the cicada tracks time, whether each developmental step is gated to the years so that reaching the final stage coincides with completing the count. The complication is that development gated only to stages could drift, and the cicada's timing is too precise to drift much. So the favored picture combines the two. The nymph reads the annual signal from the tree to keep its yearly count, while its developmental progression is coordinated with that count so that it arrives at its final emergence-ready stage in exactly the right year. The molts and the year count work together, development and timing locked in step. The straggler patterns we saw earlier fit into this picture. The tendency of off-schedule cicadas to emerge in whole number jumps, often 4 years early or late, suggests that the cycle can shift in discrete steps, perhaps when the coordination between developmental stage and year count is thrown off, advancing or delaying the nymph by a set interval. The cicada's clock in this view is not a smooth countdown but a stepped process capable of jumping by whole blocks of years when something perturbs it. This remains an area of active investigation, the details far from settled, but it points toward an answer in which the cicada's remarkable timing emerges from the interplay of 2 systems, the annual signal it reads from the tree and the staged development of its own changing body, coordinated together across 17 years into a single precise arrival. We met the broods as distinct populations, each on its own schedule. Look now at how they fit together across geography, because the full map of periodical cicada broods is a thing of real intricacy, overlapping ranges, adjacent territories, and a continent-spanning schedule of staggered emergences. The broods are distributed across the eastern United States in a complex mosaic. Each occupies its own range, but those ranges are not neatly separated. They abut one another, and in places they overlap, so that a given patch of ground might fall within the territory of one brood, while a neighboring region belongs to another, emerging in a different year. 17-year broods dominate the more northern parts of the range. 13-year broods are generally more southern, with a zone where the 2 cycles meet and even share some territory. Mapping all this has been a long scientific labor built on careful records of which cicadas emerge, where and when accumulated and refined across many decades. The result is a detailed atlas of the broods, their boundaries drawn, their emergence years known, their overlaps and gaps documented with enough precision that scientists can forecast emergences far into the future and direct observers to exactly where a given brood will appear. The overlaps are of particular interest, where the ranges of different broods meet, and especially where 13 and 17-year broods come near one another. Scientists watch closely for the rare years when emergences coincide and for any signs of interaction between the populations. These boundary zones are natural laboratories, places where the great clockwork of the broods occasionally brings two normally separate populations into the same year and the same ground. The overall picture is one of vast, organized complexity, dozens of broods, each precisely timed, tiled, and overlapped across half a continent, their collective schedule mapped and predicted a continent-scale calendar of emergencies, intricate and orderly written across the eastern forests in cicadas. We have touched on the number before, but it deserves its own moment because it captures the cicada's mathematical strategy in a single striking figure. A 13-year brood and a 17-year brood emerging in the same place will coincide only once every 221 years. The arithmetic is simple and beautiful. Because 13 and 17 are both prime, sharing no common factors but one, the only point at which their cycles realign is at their product, 13 multiplied by 17, which is 221. After a year in which both broods emerge together, it will take 221 years before that double emergence happens again in the same location. For more than 2 centuries, the two cycles run past each other without ever coinciding. Sit with the span of that. 221 years is far longer than a human lifetime, longer than many nations have existed in their current form. A person who witnessed a rare coincident emergence of a 13 and 17-year brood would know with mathematical certainty that no one alive would ever see the same coincidence again in that place. The next one lies generations beyond any living memory. These rare double emergences draw intense scientific interest precisely because they are so infrequent. When a 13-year and a 17-year brood are due to emerge together, researchers prepare to study the once-in-many-generations event. The chance to observe two great cycles normally separated by centuries, briefly aligned in the same forests in the same year. It is the prime number strategy made vivid in a single number. The cicada's two cycles are walled apart in time by the simple mathematics of primes, their meetings pushed out to intervals of more than 2 centuries. 13 and 17 do not just defend the cicada against predators and protect its broods from blurring. They space the great emergencies across spans of time so long that their coincidences become events no human will see twice. It is worth confronting directly a question. The cicada's whole strategy seems to dare us to ask why emerge all at once at all. Why pour everything into a single overwhelming pulse, rather than spreading the risk by emerging gradually a portion each year? The answer reveals the deep logic that ties the cicada's strange life together. Spreading out seems at first like the safer bet. A creature that emerged a little each year would never put its whole population at risk in a single moment. A bad year, harsh weather, a predator boom would harm only that year's small cohort, leaving the rest safely underground. Many organisms do hedge their bets this way, staggering their emergence to avoid catastrophe. But for the cicada, spreading out would be fatal to the very strategy that keeps it alive. The entire defense rests on predator satiation, on emerging in numbers so vast that predators cannot possibly eat them all. Spread that same population across many years, and in any given year, the cicadas would be few enough for predators to consume in large proportion. Worse, a steady annual supply of slow, defenseless insects would let predators build their numbers in anticipation, tuning their populations to feast on the reliable yearly crop. The cicadas would be eaten as fast as they appeared, the satiation defense destroyed. By emerging all at once, the cicada makes itself for one brief window impossible to consume, and by staying absent for the long prime-numbered years between it, denies predators any way to prepare. The all-or-nothing pulse is not reckless. It is the only configuration in which the numbers overwhelm and the timing deceives. Concentration is the whole point. So the cicada commits completely to the synchronized flood. It forgoes the safety of spreading out in favor of the far greater safety of overwhelming number achieved all at once. The strategy that looks like the riskiest possible bet, everything all together in a single moment every 17 years turns out, given the cicada's particular life, to be the most powerful defense available to it. The awe of the synchronized emergence and the cold logic of survival are in the end the same thing. There is a quiet feat of continuity in the cicada's life that is easy to overlook amid the spectacle, the way the cicada keeps faith, generation after generation, with the trees. The eggs are laid in trees, the nymphs drop and burrow to feed on tree roots. The emerging adults return to the trees to mate and lay again. Across the entire cycle, the cicada's life is bound to the forest, and it returns reliably to the kinds of trees that sustain it. When a female lays her eggs, she chooses the twigs of trees, and not just any vegetation but woody plants suitable for her young. When the eggs hatch and the tiny nymphs fall to the ground and burrow, they must find roots to feed on, and they settle in to draw sap from the trees whose root systems thread the soil around them. The whole underground life depends on having found and stayed near suitable host roots. This binds each generation of cicadas to the forest in a particular place. The nymphs feed on the roots beneath the very trees their mothers chose. The adults that emerge years later rise from beneath those trees and return to the canopy to begin the cycle again. There is a deep fidelity to place and to host in this, the cicadas tied across their long generations to the specific stands of trees that have sustained their lineage. This dependence also makes the cicada vulnerable to what happens to the forest. Where trees are cleared for development for agriculture, the cicadas beneath them lose their hosts, and a brood can be wiped from an area when the trees that fed it are removed. The cicada's loyalty to its trees is the source of its continuity, and in a changing landscape a source of its fragility. But where the forest stands, the cicadas return to it, faithfully cycle after cycle, laying their eggs in its branches, feeding on its roots through the long dark years, rising again from beneath the same trees to begin once more. A creature bound across all its strange life to the forest that has always held it. We close this stage of awe where so much of the cicada's story leads at the edge of what science has not yet figured out. The cicada runs on cycles of 13 and 17 years, switches between them across deep time, and holds its count with breathtaking precision. But the genetic basis of all this, what in the cicada's very DNA, sets the length of the cycle and governs the switch between 13 and 17, remains only partly understood. Cycle length is clearly heritable. Broods breed true 17-year cicadas producing 17-year offspring, the timing passed down faithfully through generations, and the cycle can shift the existence of both 13 and 17-year forms, and the evidence that populations have switched between them over evolutionary time shows that the cycle length can change. Somewhere in the cicada's genome lies the basis for both this inheritance and this flexibility. But precisely which genes govern the cycle, how they set the count, and how they shift it between the two prime values are questions science has not fully answered. It is a frontier of active research. Scientists studying cicada genetics seek to understand how the developmental program is set to 13 years in some lineages and 17 in others, how a population can transition from one to the other, and how the prime-numbered cycles arose and are maintained at the level of the genes. The work is difficult. The cicada's long life cycle alone makes it a hard creature to study genetically, each generation taking the better part of 2 decades to complete. And so the cicada keeps one of its deepest secrets still. We can map its broods, time its emergences, and admire the mathematics of its primes, yet the genetic machinery underwriting it all remains partly hidden. The creature performs its astonishing feat of timing. With a genetic basis, we are only beginning to read one more way the cicada, even as we marvel at it, holds something back. Pause on a simple superlative because it is one the cicada earns outright. Among all the insects in the world, and there are more kinds of insect than of almost anything else alive, the periodical cicada has the longest development known. 17 years from egg to adult. Nothing else among insects reliably takes so long. Consider the company this puts it in. Most insects are creatures of a season, sometimes of mere weeks. Fly, mosquito, butterfly, beetle, each racing from egg to adult in a span you could measure on a calendar's single page. A handful stretch their development across 2 or 3 years. But 17 years held to with precision is a category of its own. The cicada develops over a span that, for most of its insect relatives, would encompass hundreds of entire generations, rising and dying in turn. Set it against a human frame, and the strangeness deepens. A 17-year cicada, laid as an egg when a child is born, will not emerge until that child is finishing high school. The insect's single slow development spans the whole arc of a human childhood, the entire passage from infancy to the edge of adulthood, all of it unfolding underground in the dark, in one unhurried creature taking its time. It is a record that captures everything strange about the cicada's pace. In a class of animals defined by speed, by fast living, fast breeding, fast dying, the periodical cicada stands alone, at the opposite extreme, the great outlier of patience, the longest insect childhood on Earth, spent entirely out of sight, ticking slowly toward a single emergence nearly 2 decades in the making. The 17-year journey begins not in the soil but in the air, high in a tree inside the living wood of a slender twig where the female places her eggs. And the first thing the cicada ever does upon hatching is fall. The female, using the blade-like ovipositor at the tip of her abdomen, cuts a series of slits into a young twig and deposits her eggs inside the wood, tucked into the slender branch where they are sheltered. There they develop hidden in the twig for a number of weeks. Then they hatch, and out of the twig emerge the tiniest of nymphs, pale and minuscule, smaller than a grain of rice, freshly arrived into a world high above the ground. What follows is one of the small marvels of the cicada's life. These tiny hatchlings make their way out of the twig and drop falling from the branch all the way down to the earth below. They are so light that the fall does them no harm. They drift and tumble down through the air and land on the ground beneath the tree. Beginning their lives at the very surface they will not see again for 17 years. And then, almost immediately, they dig. The minuscule nymph, having fallen from the canopy to the soil, burrows down into the earth, leaving the world of light and air behind. It descends to find a root, plugs in, and begins the long underground existence that will consume nearly its entire life. It is a striking arc to begin a life on. Born high in a tree, the cicada's first act is to fall to the ground, and its second is to disappear beneath it. From twig to soil in a single tumble, the creature passes from the air it was born into the darkness it will inhabit, the long fall to earth that opens the 17-year wait. The moment the tiny nymph burrows into the soil, it vanishes from the visible world, and it stays vanished for almost the entire length of its life. This disappearance, so total and so long, is the central fact of the cicada's existence and one of the most wonder-inducing things about it. Picture the scale of the absence. A creature digs into the ground as a speck barely visible to the eye and does not return to the surface for 13 or 17 years. For all that time, it is simply gone beneath the lawns and the forest floor beneath the feet of everything that walks above, living an entire life that leaves no trace anyone above ground can see. The cicada spends the overwhelming majority of its existence as an invisible presence, present but unseen, directly underfoot, yet entirely hidden. This is why an emergence so astonishes the people who live through it. The cicadas were there the whole time, millions of them beneath the very ground people walked every day, and no one knew. There was no sign, no sound, no visible hint of the vast buried population waiting below. The forest looked empty of them. The yard looked ordinary. And all the while an immense, slow-growing multitude was living out its long life in the dark, just beneath the surface. There is genuine wonder in contemplating it. Beneath ordinary ground, in places that look like nothing at all, an entire generation of creatures can be patiently developing year after year, invisible and silent. The soil we treat as inert and empty holds in cicada country a hidden population, biding its time present beneath us for the better part of 2 decades. Asking nothing, showing nothing, simply waiting in the dark for the year it will rise. The long underground life is not a single unbroken phase. It is divided into stages, 5 of them each, separated by a molt, the nymph, passing through a series of forms as it slowly grows toward the size and development required for emergence. These stages are called instars. The cicada nymph hatches as a first instar, the tiniest form, and over the years it molts and grows into successively larger stages. Second instar, third, fourth, and finally fifth, each molt marking a step up in size and development. There are 5 of these nymphal instars in all, spread across the 13 or 17 years. The nymph spending a stretch of time in each, before shedding its skin and advancing to the next. The pace is unhurried in keeping with everything about the cicada. The years are distributed across these stages, the nymph dwelling in each instar for a span of time before molting onward. Its slow growth on thin root sap, carrying it gradually from the minuscule first form toward the substantial final. 1. By the 5th and last instar, the nymph has reached the size and maturity it needs. And it is this final stage nymph that eventually digs to the surface to emerge as an adult. It gives a structure to the long wait that mere duration does not capture. The 17 years are not an undifferentiated blank. They are a measured progression through 5 distinct stages, the nymph advancing step by step, molt by molt, growing into each new form in turn. The patience is staged, the development proceeding through its ordered sequence beneath the ground year upon year, instar upon instar, until the final form is reached and the time to rise arrives. Underlying every one of those stages is the same quiet, relentless process, the nymph drinking thin sap from a tree root year after year, growing by tiny increments on a diet that would seem to allow no growth at all. The patience of the cicada's development is at bottom the patience of this slow feeding. We have seen how meager the diet is, xylem, fluid, watery, and nearly devoid of nutrition, supplemented by the chemistry of symbiotic microbes that supply what the sap lacks. On this thin ration, growth cannot be anything but gradual. The nymph anchors itself beside a root, draws the dilute fluid through its needle of a mouth, and slowly accumulates the substance it needs drop by drop across the seasons and the years. There is no rushing it. The cicada cannot feast and surge ahead the way a richly fed insect can. Its growth is paced to the poverty of its food, a long, patient gathering of resources from an unrewarding source stretched across the better part of 2 decades. Each year adds only a little. Each instar is reached only after a long stretch of this slow accumulation. The whole development is an exercise in extracting enough eventually from almost nothing, and yet it works. From this thin sap sipped patiently across 13 or 17 years, the cicada builds an entire body. The substantial final stage nymph, equipped with everything it needs to dig to the surface, molt into a winged adult and complete its life. The slow growth on root sap is the engine of the whole long wait, unhurried, undramatic, relentless, turning a starvation diet into a finished creature through nothing but time and patience. It is wonder of a quiet kind, not the spectacle of the emergence, but the years of silent patient drinking that make the emergence possible, a creature growing imperceptibly in the dark on almost nothing toward a moment nearly 2 decades away. Lift back up from the details of the underground life and take in the whole shape of it, because the proportion alone is staggering. The cicada lives almost the entirety of its existence unseen. Of 17 years of life, all but a few weeks are spent hidden beneath the ground. The creature we know, the winged, singing adult in the trees, is the briefest sliver of the whole. Do the arithmetic of it. 17 years underground, perhaps 4 to 6 weeks above. That means something like 99.9% of the cicada's life is lived out of sight in the dark beneath the surface, and a fraction of 1% in the open air where we encounter it. The cicada we see loud and red-eyed in the summer trees is the rare exception, the visible tip of a life almost entirely buried. This inverts how we usually think of an animal. We know creatures by their visible lives, the bird in flight, the deer in the meadow, the fish in the stream. We take the seen form for the whole, but with the cicada the seen form is the merest coda. The true long life of the creature happens where we never witness it, and the version we meet is a brief final flourish. Weeks at the end of a buried existence measured in years. There is real wonder in holding both halves together, in remembering when the chorus fills the summer trees that each of those singing adults carries behind it. 17 years of invisible life, a long, dark history we never saw. The loud weeks in the canopy are the smallest part of the story. The rest, the overwhelming majority, unfolded silently underground, in a life lived almost entirely beyond our sight. After all the years in the dark, the cicada's long underground life ends with a deliberate act, the digging of a final tunnel up toward the surface, and the light it has never known in preparation for the night it will emerge. As the time approaches, the mature final stage nymph begins to work its way upward, excavating a passage from its position in the soil toward the surface. It digs with the same shovel-like forelegs that have served it underground all its life, carving a tunnel up through the earth until it nears the top, and then often it waits holding just beneath the surface, sometimes constructing a chamber or keeping the exit nearly closed, biding the final stretch of time until conditions are right. In some emergencies where the ground is damp or the cicadas, especially numerous, the nymphs build curious structures over their exit holes, little turrets or chimneys of mud rising above the surface, the cicada's tunnel topped with a small built tower. These mud chimneys are among the stranger signs of an impending emergence, the soil dotted with the cicada's constructions in the days before they rise. Then comes the night. When the soil has warmed to the threshold and the moment has arrived, the waiting nymph breaks through the last of the surface and climbs out of its tunnel into the open air, completing the journey up from the depths, emerging at last from the passage it dug onto the ground it left as a speck 17 years before. It is the final act of the buried life and the threshold of the brief life to come. The tunnel to the surface is the cicada's last underground labor, the closing of the long, dark chapter, the digging of the way out, the passage by which the creature that vanished as a hatchling returns, transformed and ready to the world. Above, set against the 17 years of waiting, the reward, the entire above-ground life, is almost cruelly brief. The cicada emerges and lives in the open air for only a matter of weeks. A few short weeks of flight and song and mating purchased at the price of nearly 2 decades underground. The disproportion is hard to absorb. Everything the long-buried life was building toward the emergence, the transformation into a winged adult, the chorus, the search for a mate, all of it plays out in a window of perhaps 4 to 6 weeks. The cicada climbs from the ground, hardens into its adult form, takes to the trees, and within that brief span must accomplish everything its whole existence has been preparing for before its short life in the air runs out. There is a poignancy to it that is impossible to miss. 17 years of patient development, of slow growth in the dark, of holding the count across the long wait, and then a few weeks of frantic living in the end. The adult life is a brief, bright flare at the close of a long, slow burn. The whole spectacle of the emergence compressed into a sliver of time at the very end of the creature's existence. And yet in those weeks the cicada lives completely. It fills the forest with sound, takes to the air it has waited 17 years to enter, finds its mate and passes on its life to the next generation. The brevity does not diminish the living. If anything, it concentrates it. Everything that matters happens in those few weeks urgently and fully. The cicada spending in a brief burst all the life it spent so long preparing for. It is the central wonder and the central poignancy of the cicada's existence held together a creature that waits 17 years to live for weeks, and in those weeks, lives entirely before the long story closes. Within that brief window of adult life, the cicada accomplishes the entire purpose of its emergence and then dies. Mating, egg-laying, and death all unfold within roughly a month, the whole reproductive culmination of 17 years compressed into a few crowded weeks. The sequence moves quickly. The males emerge and begin to sing, gathering into chorus centers, filling the forest with the sound that draws the females. The females arrive, the courtship duets play out, and mating follows. Then the females turn to the work of laying, cutting slits into twigs with their ovipositors and depositing their eggs in the wood. Often hundreds of eggs placed across many twigs in the brief time they have. And then their purpose fulfilled, the adults die, the males and females alike reaching the end of their short above-ground lives, the great emergence collapsing into the die-off we saw at the very start. It is a month of total expenditure. Everything the cicada has, all the resources and development banked across 17 underground years, is spent here in this final burst of singing and mating and laying. There is no holding back, no reserve kept for later, because there is no later. The adult life is the all-out terminal spending of everything the long wait accumulated, and when it is done, the cicada is done. The eggs left behind in the twigs are the whole point of it, the next generation, already placed, already beginning to develop in the wood. The adults that made them are dying, even as the eggs sit waiting to hatch, the old generation passing away precisely as the new one is set in motion. Within a single month, the cicada mate secures its succession and dies, closing its own life in the same brief span that opens the life of its young. 17 years of preparation, a month of fulfillment, and an ending, the whole adult life, a swift, complete and final act. Lay the numbers side by side and the cicada's life resolves into one of the most lopsided equations in all of nature. Years of waiting, 13 or 17 of them for days or weeks of flight. The ratio is so extreme it reads almost as a riddle. What creature spends nearly its whole life preparing to live and then lives for the briefest moment? Think of it as a fraction. The denominator is enormous, 17 years, the better part of 2 decades, all of it spent underground. The numerator is tiny, a few weeks at most of actual adult life in the open air. Divide the one by the other, and you get a number vanishingly small, a life in which the visible active, flying phase is a rounding error against the vast buried weight that precedes it. No human pattern of life resembles this. We spend our years in proportion childhood, then a long adulthood lived out in the open. The cicada does the opposite. It loads almost the entire span of its life into a single dark waiting phase and reserves only the final flicker for everything we would call living. It is as though a person spent a lifetime in preparation and then lived fully, only for a final handful of days. And yet the math is not a tragedy from the cicada's point of view, it is a strategy and a successful one. The long wait is not wasted time. It is the engine of the whole approach. The patience that makes the synchronized, overwhelming emergence possible. The years underground by the safety of the prime-numbered cycle and the power of predator satiation. The brief flight is not cheated by the long wait. It is made possible by it. Still held in the mind as pure arithmetic, the cicada's life is staggering. Years for days. Nearly 2 decades of darkness for a few weeks of light. A creature that pays in patience an almost unimaginable price for the short, bright window of its flight. There is a charming way to frame the synchrony that makes its scale suddenly vivid. An emergence is in effect billions of birthdays falling on the same few days. Every cicada in the brood began its life at roughly the same time, 17 years before, and now reaches its culmination together, a vast shared anniversary observed across an entire region at once. Think of it that way and the coordination becomes almost personal. All these creatures scattered across the soil of many states began as eggs in the same season, 17 years ago hatched and fell and burrowed in the same stretch of time and have lived parallel lives underground, each on the same schedule, all counting toward the same year. Now they surface together, a generation that shares not just a birth year but very nearly a birth week, all of them arriving at adulthood in the same brief window. It is a synchrony of life stages on a staggering scale. Human birthdays scatter across every day of the calendar. The cicadas of a brood concentrate theirs into a single shared moment. Billions of individual lives all reaching the same milestone at once. Across a vast region, the whole generation comes of age together, in a coordinated maturation that has no real parallel in the creatures we know best. And it deepens the sense of the brood as a single distributed entity moving through time together. The cicadas are not just individuals who happen to emerge in the same year. They are a cohort, a generation bound by a shared schedule, living their long lives in parallel and arriving at the end together. Billions of synchronized birthdays, observed in the same few days across the eastern forests, the brood's whole generation, turning the same age and coming into its brief adulthood all at once. The great die-off, which we first met as drifts of bodies and a thick smell of decay, has another face, entirely one of generosity. When billions of cicadas die at once and their bodies return to the forest floor, they deliver an enormous pulse of nutrients into the ecosystem, a vast fertilization that the forest takes up and uses. Consider the sheer mass involved. 1,000,000,000,000 cicadas, having drawn resources from tree roots across 17 years, all die within the same brief window and fall to the ground. Their bodies decompose together, releasing into the soil the nutrients they accumulated over all those years, a sudden massive infusion of nitrogen and other elements, deposited across the forest floor in a single concentrated event. It is one of the largest pulses of nutrients a temperate forest ever receives from animals. The forest responds. The decomposing cicadas enrich the soil, and the trees and plants take up the released nutrients, with studies finding measurable boosts to plant growth in the wake of an emergence. The very trees that fed the nymphs for 17 years, sap drawn slowly from their roots, receive in the end a great return. The accumulated substance of the cicadas given back to the soil, taken up again by the forest that produced it. There is a beautiful circularity to it. The cicadas drew from the trees across their long underground lives, slowly drop by drop, and in death, all at once, they give it back, their bodies fertilizing the ground, feeding the next generation of plant growth, returning to the forest the resources they borrowed from it. The die-off that smells of decay is also an act of renewal, a vast pulse of fertility delivered to the forest floor. So the end of the emergence is not merely an ending, it is a giving back billions of lives having taken slowly from the forest for 17 years, returning everything at once in a single great pulse of nourishment, closing the long loop between the cicadas and the trees that held them, return to the human scale of the 17-year cycle, because it holds a particular kind of wonder, the way a single brood cycle maps onto the arc of a human life, marking time in a person's own years. A child born in the year of an emergence will be 17 when that same brood emerges again on the verge of adulthood, the whole of childhood having passed in the interval between one emergence and the next. The brood's single cycle spans exactly the distance from birth to near adulthood, from infancy to the cusp of grown life. The cicadas measure out in one turn of their clock the entire passage of a human childhood. This gives the broods a strange power to mark the chapters of a human life. People remember where they were at the last emergence and find themselves transformed at the next 17 years of their own lives having unfolded in the gap. A person might experience an emergence as a young child, the next as a young adult, the next in middle age, the next in old age, the brood returning across the decades as a recurring marker, each appearance finding the person at a wholly different stage of life. There is something quietly profound in being able to measure your own life against a brood's. The cicadas keep a slower time than we do, but a time that intersects ours at long intervals, and at each intersection we are someone new, while the cicadas perform again the same ancient emergence. The brood is unchanged. We are changed. The cicadas mark our years more vividly than almost anything else in nature, precisely because their cycle is long enough to catch us at different ages each time it comes around. A single brood, spanning a childhood to an adulthood, a clock slow enough to measure out the chapters of a human life. Even as the adult cicadas die and the great emergence collapses into decay, the next cycle is already quietly beginning. In the twigs above the eggs the females laid are developing, and in time they hatch, and the tiny nymphs fall to earth and burrow, and the whole 17-year wait begins again in silence, just as the spectacle of the parents' generation ends. The timing of it is poignant. The adults are dying, the chorus fading, the bodies falling at the very moment their offspring are preparing to begin. The eggs, tucked into the twigs weeks earlier, complete their development and hatch into minuscule nymphs which make their way out of the wood and drop to the ground below exactly as their parents did 17 years before. And then they dig in and disappear, and the long underground life starts over. There is no fanfare to this restart. The emergence was deafening, overwhelming, impossible to miss. The beginning of the next cycle is the opposite, utterly silent, utterly hidden, a scattering of tiny new nymphs vanishing into the soil with no sound and no sign. The loud generation ends in spectacle. The new one begins in secret, the great clock quietly reset to zero beneath the ground. And so the cycle closes and opens in the same motion. The old generation's death and the new generation's birth, overlap the adults expiring above as the nymphs burrow below the end of one 17-year story, feeding directly into the start of the next. The forest falls quiet, the bodies decay into the soil, and beneath it all a new generation invisibly begins its long count toward an emergence, 17 years away. The silence after the roar is not empty. It holds the beginning of the next cycle, the eggs hatched, the nymphs gone to ground, the clock ticking again from the start, in the dark where it always does. Step back and consider the cicada's cycle not as biology but as time itself, a clock that runs so slowly it outlasts the details of human memory, returning across spans long enough that we half forget it between appearances. There is a particular wonder in a natural rhythm pitched to this scale, slower than the seasons we track, long enough to slip the edges of recollection. 17 years is long enough that between emergences the last one fades. People forget the exact year, the precise intensity, the feel of standing inside the roar. Children who lived through one emergence are nearly grown by the next, and may scarcely recall the first. The cicada's clock runs at a tempo that exceeds the easy reach of memory, so that each emergence arrives with a quality of half surprise, a rhythm we know is coming, but cannot quite hold in mind across the long gap. This sets the cicada apart from nearly every other natural cycle we live by. The day, the month, the year, the seasons, these turn quickly enough that we hold them easily, their rhythms woven into ordinary memory. The cicada's cycle is too slow for that. It belongs to a longer order of time, one that spans the better part of 2 decades, returning at intervals that brush against the limits of what a person readily remembers. And there is wonder in encountering a living thing that keeps such time. The cicada embodies a rhythm longer than our own easy recall, a clock that ticks in the background of human lives at a pace we can barely track, marking out the years in spans long enough to outlast the sharpness of memory. It returns each time, as something both expected and half forgotten, a creature whose very cycle is pitched to a scale of time that exceeds the reach of the mind that observes it. A clock that outlasts memory. The cicada keeps it faithfully in the dark across the long years, and we meet it again each time, as if remembering something we had nearly let go. To feel the cicada's patience, fully hold it against the timescales of a human life, not in the abstract but concretely, year against year. 17 years is not a number. It is a span you have lived, a stretch of your own life you can measure the cicada against. And the comparison is humbling. 17 years ago, call up what that means for you. The person you were, the place you lived, how much has changed in the interval. Across all of that, all the events and changes that have filled your own 17 years, a single cicada has been underground doing one thing, waiting. Through everything that has happened in your life, the cicada has been below the soil, drinking sap, slowly growing, holding its count, patient and unchanging, while your whole stretch of years unfolded above it. It reframes patience entirely. We speak of waiting for hours, for days, occasionally for years. The cicada waits for the better part of 2 decades, a span across which human lives transform completely, across which children become adults and adults grow old. And it waits not in fits, and starts not with distraction or relief, but continuously in the dark for the whole of that time, toward a single emergence at the end. No human patience compares. We could not hold still for 17 years doing one thing, waiting for one moment. The cicada does exactly this, as the ordinary condition of its life. Patience not as an achievement, but as a way of being sustained across a span that dwarfs any waiting we know. To measure the cicada against your own years is to feel the strangeness of its pace land fully. The whole arc of your recent life, all its change and motion set against one creature's single unbroken wait in the dark. 17 years of your time lived as the cicada's one long pause, patience on a scale that puts every human waiting to shame. Because the cicada's cycle is so long, a single brood becomes something passed down across human generations, witnessed by grandparents, parents, and children. In turn, a shared inheritance of memory tied to the same returning emergence. The brood outlives the individual memories of it, threading through a family's generations as a recurring event held in common. Imagine a particular brood emerging in a particular region every 17 years. A grandparent might have witnessed it as a child. A parent witnessed the next emergence. The child witnesses the one after that. The same brood on the same ground, returns across the generations of a single family, each generation meeting it at a different point in their lives. The emergence becoming a thread of shared experience, running down through the years. This gives the broods a place in human continuity that few natural events can claim. They become markers passed between generations, the year the cicadas came remembered and retold, anticipated by those who recall the last time, and described to those too young to have seen it. The long cycle means that witnessing a brood is something handed down, the memory of one emergence carried forward to frame the next families and communities, marking their own continuity against the cicada's return. There is a quiet beauty in this intergenerational sharing. The cicadas keeping their slow time become a common reference point across the span of human lives, an event that links a grandparent's childhood to a grandchild's, the same emergence witnessed by people separated by decades, all of them having stood at different times inside the same, returning roar. The brood endures across the generations that witness it, a shared inheritance of memory and anticipation, tying human continuity to the long, faithful rhythm of the cicada's return, a natural event slow enough to be handed down like a story from one generation to the next. For all the power of the emergence, the overwhelming numbers, the deafening roar, the individual adult cicada is a fragile thing, its brief life in the open air, precarious and easily ended. The contrast between the might of the brood and the frailty of the single cicada is one of the quieter wonders of the whole phenomenon. The adult cicada is not built to last. Its weeks-long life is lived on borrowed time from the moment it emerges, vulnerable to predators, to weather, to the simple running out of its short span. It is a clumsy flyer, easily caught. It has no real defenses as an individual. Its only protection was ever the overwhelming number of its brood, the safety of the crowd. Pull a single cicada out of that protective flood, and it is a soft, slow, defenseless creature, its life measured in days. And even unharmed, the adult life is simply brief by design. The cicada emerges, lives its few weeks and dies, its body not made for endurance in the open air, its existence above ground always meant to be short. The fragility is built in. The whole point of the adult phase is to accomplish reproduction quickly and then end. Longevity was never part of it. There is poignancy in setting this individual frailty against the collective power of the emergence. The brood is mighty, billions, strong, overwhelming, impossible to resist. But each cicada within it is delicate, short-lived, easily lost its brief flight, a fragile thing against the vastness of the whole. The strength was always in the number, never in the individual. The single cicada was always meant to be expendable, fragile, brief. The weeks-long adult life, for all the spectacle it joins, is a fragile flicker, a soft and short-lived thing, mighty only in its multitudes, delicate and fleeting on its own. At the heart of the emergence lies a transformation so complete that it turns one creature into what seems like another entirely. The pale, blunt, soil-bound nymph, becoming the winged, red-eyed adult of the trees. It is metamorphosis, and watching it is to watch a creature remake itself before your eyes. The nymph that climbs from the ground is a thing of the soil, pale-armored, equipped with digging arms built for the dark. Anchored to its perch, it splits its old skin down the back and begins to draw itself out, and what emerges is startlingly different. Soft and ghostly white at first, it pumps fluid into crumpled wing pads until they unfurl into broad, clear wings. Its body hardens and darkens, its color arrives, and within hours the soil creature has become an adult, built for air-winged mobile, ready to fly and sing. The completeness of the change is the wonder of it. This is not a gradual growing up, but a wholesale transformation. The digging nymph and the flying adult, so different in form, in capability, in the world they inhabit, that they scarcely seem the same animal. One is built for burrowing in the dark, the other for flight and song in the sunlit canopy. And yet they are a single creature, the one becoming the other in the span of a single emergence. To witness it is to watch a life turn a corner so sharp it borders on the impossible. The patient, pale digger of 17 underground years, becoming in a few hours on a tree trunk at night, the loud winged adult of the brief, bright weeks, to come. The shovel arms give way to wings, the dark adapted body to one made for sun and air. The same individual transformed utterly, crossing from one form of life into another. The transformation from nymph to adult is the pivot of the whole story, the moment the buried creature becomes the flying one, the long, dark life giving way in a single remaking to the short, bright one. Gather the whole arc of the cicada's life into a single impression, and what remains is stillness. For all the noise and motion of the emergence, the cicada's existence is overwhelmingly a still, 1 year of quiet, patient, nearly motionless waiting in the dark, with only the briefest burst of activity at the very end. Picture the proportions one last time. 17 years anchored beside a root, drinking, slowly growing imperceptibly, scarcely moving, a life of stillness so prolonged it is hard to imagine. And then a few weeks of frantic motion, the climb, the transformation, the flight, the song, the mating. The motion is real and intense, but it is a sliver. The stillness is the substance. The cicada is, for almost the entirety of its life, a quiet and nearly motionless creature waiting in place in the dark. This is the deep character of the cicada that the loud emergence can obscure. We meet it as the noisiest insect in the forest, a creature of overwhelming sound and restless flight. But that is the exception, the brief final flourish. The true cicada, the one that exists for almost all of its years, is silent and still, a patient, near motionless waiter, holding its place beside a root through the long, dark span of its life. There is a kind of peace in recognizing this, and a kind of wonder. The cicada's life is not at heart the riot of the emergence. It is the long stillness that precedes it, the years of quiet waiting that make up nearly the whole of the creature's existence. The roar is real, but it is brief. The stillness is the life. A lifespan mostly spent in stillness, in the dark, in patient waiting, the quiet truth beneath the loudest spectacle in the forest. And that stillness and all it has meant across the immense reach of the cicada's history is where the story turns at last toward its close. To understand what the cicada is, you have to set it against time on a scale that dwarfs even its 17-year cycle. Cicadas as a group are ancient, their lineage reaching back across vast stretches of evolutionary history, far older than humanity, far older than the forests we know, deep into the long past of insect life on Earth. The cicadas belong to an old order of insects, and their kind has been singing in the world's forests for an immense span of time, tens of millions of years and more. The basic form of the cicada, persisting across epochs that have seen continents shift and entire worlds of other creatures rise and vanish. Long before there were people to hear them, cicadas were filling ancient forests with sound, drinking from the roots of trees that have themselves long since passed into fossil and stone. The periodical cicadas, with their extraordinary prime-numbered cycles, are a particular branch of this ancient stock, a remarkable evolutionary innovation but built upon a foundation of deep antiquity. The strategy of long, synchronized prime-numbered emergence was honed over great spans of time, refined across countless cycles into the precise phenomenon we witness today. It is not a recent curiosity, but the product of an immense evolutionary history, shaped slowly, like everything about the cicada, across the long reach of deep time. There is weight in placing the cicada against this backdrop. The creature we encounter for a few weeks in a summer forest carries behind it not just its own 17 years, but the inheritance of an ancient lineage, stretching back beyond all human reckoning. When the chorus rises, it is an old sound, older than our species, older than our forests. A song that has been part of the world for far longer than we have. The cicada is a deep survivor, carrying the long history of its kind into the present, emerging now, as it has emerged across unimaginable spans of time before. For all that the cicada can seem like an isolated marvel, it is woven deeply into the life of the forest, playing roles in its ecosystem that extend through the soil, the trees, and the web of creatures that feed upon it. The cicada is not a spectacle apart from nature. It is a working part of it, contributing to the forest in ways both obvious and subtle. Underground, across their long lives, the nymphs work the soil. The countless tunnels they dig, the constant movement of millions of nymphs through the earth over 17 years, aerate and turn the soil, creating channels and disturbances that affect its structure and the movement of water and air through it. When they finally emerge, the multitude of exit holes further opens the ground, the forest floor left punched through with passages. In their digging, the cicadas are quiet engineers of the soil, reworking the earth across the span of their buried lives. Above ground, And at the end, as we have seen, they feed the forest the great die-off, returning a vast pulse of nutrients to the soil, fertilizing the very trees that sustained them. And throughout the emergence, they feed the forest's animals, the overwhelming flush of cicadas, nourishing predators of every kind, a bounty that ripples through the food web. The cicada is, in its emergence and its death, a massive transfer of resources through the ecosystem, drawn from the trees across years, released to predators and soil in a concentrated pulse. These ecological roles give the cicada a significance beyond its strangeness. It aerates the soil, feeds the forest in death, and nourishes the web of predators in life. A creature embedded in the functioning of its ecosystem, its long underground labor, and its brief explosive emergence, both contributing to the forest. That holds it. To remove the cicada would be to remove a working part of the system, a participant whose roles, quiet and dramatic alike, help shape the forest around it. The emergence is so vast, a pulse of food, that its effects ripple outward through the predator community and persist long after the cicadas themselves are gone, reshaping the populations of the animals that feast upon them, sending waves through the food web that last for years. When billions of cicadas flood the forest, the predators that eat them enjoy a bounty beyond anything in their ordinary experience. Birds and mammals and other predators gorging on the abundance are better fed than usual, and a well-fed predator population tends to thrive and reproduce more successfully. In the wake of an emergence, some predator populations swell, boosted by the extraordinary feast, their numbers rising in response to the sudden glut of easy food. But the cicadas vanish as quickly as they came, and the predators are left in following years with their elevated numbers and no more cicada bounty to sustain them, a disruption that can ripple through the food web for years afterward. The boom in predators may shift the pressures on other prey species. The subsequent return to normal cicadaless conditions may bring its own adjustments. Researchers have traced effects of emergences rippling through ecosystems for several years. The great pulse of cicadas disturbing the balance of the food web well beyond the weeks of the emergence itself. This is the long ecological shadow of the emergence. The cicadas are present for only weeks, but the consequences of their flood persist, populations boosted and then left, wanting pressures shifted, and then readjusting the food web, absorbing the great pulse and slowly settling afterward. A single emergence sends ripples forward through years of ecological time, its effects outlasting the cicadas many times over. It deepens the sense of the emergence as a major ecological event, not a passing curiosity. The flood of cicadas reshapes the living community around it, and the forest carries the consequences forward, adjusting in the years that follow to the great pulse that came and went. The cicada's brief presence leaving a long, ecological wake. The relationship between cicadas and humans is not only one of spectacle and unease. For a very long time in many cultures, cicadas have been food, gathered, eaten, and valued as a seasonal source of nourishment, the great emergence treated not as a plague but as a harvest. Across various cultures and through history, people have eaten cicadas, and the periodical emergence, a sudden gatherable abundance of protein-rich insects, offered an opportunity that did not go unused. Indigenous peoples of North America are known to have eaten periodical cicadas, gathering them during emergences as a food source. And cicadas have featured in the diets of many other cultures around the world as well. They are typically collected in their soft, freshly emerged state when they are at their most edible and prepared in various ways. To people who treated them as food, an emergence was a windfall, a vast, easily gathered abundance, arriving all at once, a seasonal bounty of nourishment delivered by the forest. Where settlers saw a biblical plague, others saw a harvest. Where some recoiled, others gathered. The same overwhelming flush of insects that struck fear into the unprepared was to those who knew how to use it, a gift of food on a remarkable scale. This reframes the cicada's relationship to humanity. It is not only the creature that overwhelms and unsettles, it is also, in a long human tradition, a creature that feeds a source of sustenance woven into the foodways of peoples who lived alongside the emergences and learned to make use of them. The cicada has been to humans both a spectacle to fear and a harvest to gather, the response depending entirely on the eyes that met it. There is weight in remembering this older relationship, a reminder that the cicada has long been part of human life in practical, sustaining ways, not merely as a wonder or a disturbance, but as food gathered from the forest in the brief abundance of the emergence. The cicada's extraordinary timing, the precise count to 13 or 17, the synchronized emergence keyed to soil temperature, was tuned across vast evolutionary time to the climate the cicada evolved in. But that climate is now changing, and there are signs that a warming world is beginning to affect the cicada's timing, with consequences that scientists are watching closely. The cicada's emergence depends on temperature on the soil warming to its threshold, and across the years on the seasonal signals the nymph reads from the trees. As the climate warms, these temperature-driven cues shift. Warmer conditions can affect the pace of the nymph's development and the timing of their emergence. And there is concern and evidence that warming is contributing to cicadas emerging earlier or off their expected schedule in ways that may disrupt the finely tuned synchrony the whole strategy depends on. The phenomenon of stragglers, cicadas emerging years early or late, may be linked to these shifting conditions, and some scientists worry that a warming climate could increase such off-schedule emergences, potentially threatening the tight coordination that makes predator satiation work. If warming pushes more cicadas off the synchronized count, the overwhelming number defense could be weakened. The brood's precise timing eroded by a climate changing faster than the cicada's ancient clock can adjust to. There is real weight in this. The cicada's timing is a masterpiece of evolutionary tuning calibrated across immense time to a particular climate, and now the climate is changing within the span of a few human generations, far faster than the slow processes that shaped the cicada's clock. A creature whose entire strategy rests on precise timing faces a world in which the temperature cues it depends on are shifting beneath it. What this will mean for the cicada over the coming decades is uncertain, and it is one of the open questions that hang over the creature's future. The ancient clock, tuned to a stable climate, now ticks in a warming world, and whether it can keep its remarkable time as conditions shift is a question still unfolding. The broods are not eternal. Across history, some have dwindled and vanished, going extinct quietly, often unnoticed, their long cycles broken, their territories fallen silent. The great clock in that ground stopped for good. And this fragility is one of the soberer notes in the cicada's story. Periodical cicada broods have been lost. Records and historical accounts point to broods that once emerged in particular regions and emerged no longer populations that have disappeared. Their 17-year cycles ended the cicadas that once filled those areas gone. The causes are various. The destruction of the forests, the cicadas depended on the fragmentation and development of their habitat, the disruption of the conditions their long cycle required. When the trees that fed a brood are cleared, the cicadas beneath them lose their hosts, and a brood can be extinguished from an area as its forest is removed. What makes these extinctions especially poignant is how quietly they happen. A brood emerges only once every 17 years. Its absence in a given year is not necessarily noticed, and the realization that a brood has vanished may come only slowly after the expected emergence simply fails to arrive again and again. A creature that is invisible for 17 years at a stretch can slip out of existence almost unremarked, its disappearance registered only by the silence where a roar should have been. There is weight in contemplating the loss of something so ancient and so precisely tuned. A brood represents an unbroken chain of cycles, stretching back through deep time each generation, faithfully handing the count to the next across thousands of years. When a brood goes extinct, that long chain is severed, a lineage of extraordinary timekeeping sustained across the ages, ended in the span of a few human decisions about land and trees. The quiet extinction of broods is a reminder that even a creature this ancient and this remarkable is vulnerable, that the great clock, for all its precision and antiquity, can be stopped and stopped so quietly that few even notice the silence where the cicadas used to be. The cicada's life, the long burial, the emergence into light, the transformation, the song has spoken to human imagination for millennia, and across cultures, the creature has become a symbol carrying meanings of rebirth, resurrection, patience, and the soul. The cicada is not only a biological marvel, it is a creature laden with human meaning, woven into myth and symbol across the world. The arc of the cicada's existence lends itself naturally to symbolism. A creature that spends years buried in the earth and then emerges transformed into the light that sheds its old shell and rises as a winged adult offers an almost irresistible image of resurrection and rebirth of life returning from the break, dark of transformation and renewal. Across cultures, the cicada has been read this way, its emergence from the ground and its molting into winged form taken as emblems of the soul's survival of rebirth of life, triumphing over death. It has also stood for patience, for the rewards of long waiting, for the virtue of enduring through a long, dark span toward a moment of fulfillment. And its song filling the summer has carried its own associations of summer itself, of the passage of seasons of voice and persistence. In the art, poetry, and belief of various cultures, the cicada appears again and again. Its biology transmuted into meaning, its strange life made to speak of human hopes and human truths. There is weight in recognizing how deeply the cicada has entered human culture. The creature that fills the forest with sound is also a creature that has filled human imagination, a symbol carried across centuries and civilizations. Its emergence from the earth read as rebirth, its long wait read as patience, its molted shell read as the soul leaving the body behind. The cicada lives not only in the forest but in the human mind, where its remarkable life has long been a source of meaning. To know the cicada fully is to know both its biology and its symbolism, the creature itself and the meanings humanity has drawn from it across the long span of our shared history. The symbolic weight of the cicada has found expression in the specific words, stories, and images of cultures around the world, in poetry that invokes the cicada's song, in myths that give it meaning, in memories that bind the creature to place and season. Across many civilizations, the cicada has left its mark on human expression. In the ancient Mediterranean world, the cicada appeared in poetry and myth. Its songs celebrated its image, carrying associations of music, of summer, of the divine. In the literary and artistic traditions of East Asia, the cicada has been a recurring and resonant figure woven into poetry and art. Its voice and its life cycle laden with meaning. Its image used to evoke seasons, transience, and renewal. Across cultures and centuries, poets have reached for the cicada's song to capture the feeling of summer, the passage of time, the persistence of a voice rising from the trees. And in the lived memory of communities, the cicada, and especially the great periodical emergence, has become part of local identity and recollection. The emergence enters the collective memory of the people who witness it, a shared event woven into the story of a community. Recalled across the years between appearances, there is weight in seeing how widely and how deeply the cicada has threaded through human expression. It is a creature that has earned a place in our poetry, our myths, and our memories. Its song captured in verse, its life given meaning in story, its emergence held in the collective recollection of communities. The cicada has been across the long span of human culture, not just an insect, but a presence, a voice, and an image that humanity has returned to again and again to speak of summer and time and renewal. To stand in the cicada's chorus, then, is to stand within a sound that has echoed through human culture for millennia. A song that poets have praised, that myths have honored, that memory has held rising now as it has risen through a long history of people who have stopped to listen. We return near the end to the great die-off, to the meaning of that vast death and what it ultimately gives back to the living world. The end of the emergence, for all its drifts of bodies and thick smell of decay, is finally an act of return, the cicadas giving back to the ecosystem everything they drew from it across their long lives. Across 17 years, the cicadas took from the forest, drawing fluid from tree roots, accumulating in their bodies the resources of all those years. And in death, all at once, they return it, their bodies decomposing into the soil, releasing their stored nutrients in a single great pulse, feeding the forest floor and the trees and the plants that take the nutrients up. What was drawn slowly is given back suddenly, the long withdrawal repaid in one concentrated deposit. This return ripples through the ecosystem. The enriched soil boosts plant growth. The pulse of nutrients enters the forest's cycles. The resources the cicadas gathered across their buried lives are redistributed into the living forest. The death of the cicadas is not a loss to the ecosystem, but a transfer the great mass of the brood converted through decay into nourishment for the system that produced it. There is a quiet weight in seeing the die-off this way. What strikes the human observer as grim, the piles of bodies, the smell of decay, is in the economy of the forest, an act of profound generosity. The cicadas, having lived their long lives at the forest's expense, repay the debt in full at the end, their bodies feeding the very ground they rose from. The ending that smells of death is, in truth, a giving of life. The cicadas returning to the ecosystem, all at once, everything they took across the years. It closes the loop between the cicada and the forest. Drawn slowly from the trees, given back suddenly to the soil, the resources cycle through the cicada and return the creature's death, feeding the forest's life, the long withdrawal and the sudden return, completing a circle that has turned in that ground for ages. We met the fungus Massospora earlier in the uncanny stage, the parasite that hollows out the cicada and hijacks its drives. Return to it now in the register of weight, because the fungus represents one of the genuine frontiers of the unknown in the cicada's story, a mystery that science is still working to understand. The fungus does something profound and unsettling. It manipulates the behavior of its host, driving the infected cicada to keep mating, keep moving, keep spreading the fungus even as its body is consumed. How a fungus achieves this, how it reaches into the behavior of an animal and bends it to the parasite's purpose, is a question of deep scientific interest, touching on the broader and still poorly understood phenomenon of parasites that manipulate their host's behavior. Researchers have found that the fungus produces psychoactive compounds, substances that may act on the cicada's nervous system, and have begun to investigate how these chemicals might drive the altered behavior. But much remains unknown. The full mechanism by which the fungus commandeers the cicada's drives, the precise ways it alters behavior to ensure its own spread, the deeper biology of this grim partnership, these are questions still being explored, the fungus holding secrets that science has only begun to uncover. There is weight in this mystery. The cicada, already a creature of profound unanswered questions, hosts within its story another deep enigma, a parasite that manipulates behavior by means not yet fully understood. A frontier of biology playing out in the bodies of the comparidae. Emerging cicadas. The fungus is a reminder that even within the well-studied phenomenon of the cicada, there are dark corners. Science has not yet illuminated processes at work that we observe but do not yet fully comprehend. It is one more of the cicada's unsolved questions, the manipulating fungus hollowing and steering its host by means we are still struggling to understand, a mystery riding within the larger mystery of the cicada itself. We touched on the quiet extinction of broods. Sit now with the why of it, because the reasons carry real weight, and because they point to the cicada's vulnerability in a world increasingly shaped by human hands. Broods are vanishing from ranges they once occupied, and the causes lie largely in what has happened to the land. The cicada's deep dependence on trees is the root of its vulnerability. The nymphs feed on tree roots. The brood is bound to the forest above it. When that forest is cleared for development, for agriculture, for the spread of human settlement, the cicadas lose the hosts their lives depend on, and the brood in that ground can be extinguished. As forests have been fragmented and converted across the cicada's range, the habitat that sustains the broods has been diminished, and with it in places the cicadas themselves. Where once a continuous forest held a thriving brood, now there may be scattered patches amid development, and the brood may dwindle, its numbers falling, its range contracting, until in some places it vanishes altogether. The cicada's loyalty to its trees, the source of its long continuity, becomes in a changing landscape the source of its undoing, for where the trees go, the cicadas cannot follow. There is weight in recognizing that the vanishing of broods is in significant part a human-caused loss. These are not mysterious disappearances, but often the direct consequence of the destruction and fragmentation of the cicada's forest habitat, a creature of extraordinary antiquity and precision diminished by the clearing of the trees. It has depended on across the ages. It places a quiet responsibility within the cicada's story. The broods that have vanished, and those that may yet vanish, are tied to the fate of the forests, and the fate of the forests increasingly lies in human hands. The cicada's vulnerability is bound to our choices about the land, its continuity dependent on the survival of the trees that have always held it. Among all the cicada's mysteries, one stands out for its depth and its difficulty, the question of how the prime-numbered clock evolved in the first place. We can admire the elegance of the 13 and 17-year cycles, trace their advantages, marvel at their precision, but how this extraordinary timing actually arose across evolutionary history remains a profound and only partly answered question. The puzzle is genuinely hard. How did cicadas come to develop cycles of exactly 13 and 17 years, these particular primes, out of the long process of evolution? What were the steps along the way? The intermediate forms, the pressures that pushed the cicada toward ever longer and ultimately prime-numbered cycles. Scientists have proposed ideas, the advantages of predator satiation, the benefits of avoiding predator and competitor cycles, the role of climate history, and the pressures of past ice ages in favoring long cycles. But the full evolutionary story, the precise path by which the prime-numbered clock came to be, is still being pieced together. The difficulty is compounded by the cicada itself. A creature with a 17-year life cycle is extraordinarily hard to study across the timescales evolution requires. Each generation takes the better part of 2 decades, and the deep history of how the cycles evolved is locked in a past that leaves little direct evidence. Scientists work with the patterns they can observe, the genetics they can read, the models they can build, but the origin of the prime-numbered clock remains in important respects an open question. There is real weight in this unanswered question. The cicada performs one of the most remarkable feats of timing in all of nature, and how that feat came to be, how evolution arrived at these precise primes across the long history of the lineage, is something we do not yet fully understand. The clock keeps perfect time, and we can only partly explain how it was built. It stands as one of the deep, open questions the cicada poses, the mystery not just of how the clock works, but of how across the vast reach of evolutionary time, such a clock ever came to exist at all. The prime-numbered strategy has carried the cicada through immense spans of time, but it evolved in a climate that is now changing, and one of the gravest open questions about the cicada's future is whether a warming world will ultimately break the strategy that has sustained it for so long. The whole power of the prime-numbered cycle rests on precision and synchrony on the brood, emerging together on the exact 13 or 17-year count, on the timing that overwhelms predators and keeps the broods distinct. But this precision evolved under a stable climate, and as warming shifts the temperature cues, the cicada depends on that precision may be threatened. If warming pushes more cicadas to emerge off schedule, disrupts the synchrony, or alters the developmental timing, the prime-numbered strategy could be undermined, the coordination eroded, the overwhelming number defense weakened, the careful separation of the broods blurred. The concern is that the climate is changing far faster than the cicada's clock can evolve to match. The prime-numbered cycle was tuned across vast evolutionary time. It cannot be retuned in a few human generations. If the climate shifts faster than the cicada can adapt, the ancient strategy so successful for so long may find itself mismatched to a world it was not built for. Its precise timing thrown off by conditions changing too quickly for evolution to track. What this will mean is genuinely uncertain, and that uncertainty is itself the weight of the question. We do not know whether the cicada's remarkable strategy will hold in a warming world, or whether the precision that has sustained it for ages will begin to fail. The possibility hangs over the cicada's future that the very strategy that made it one of nature's great survivors could be undone by a climate changing faster than its ancient clock can answer. It is a sobering question to set against the cicada's deep antiquity, whether a strategy honed across millions of years will survive the rapid changes of a single human era, or whether the great clock, having kept its time so faithfully for so long, will finally be broken by a world transforming too fast around it. The cicada and the forest are bound together across time in a relationship of deep mutual significance. The cicada dependent on the forest for its very life, and the forest in turn shaped and served by the cicada in ways that speak to its long-term health. To consider the cicada fully is to see it as part of the forest's own long life. The cicada depends utterly on the forest, on the trees whose roots feed the nymphs, whose twigs cradle the eggs, whose canopy hosts the emerging adults. Its entire existence is woven into the forests, its life cycle inseparable from the trees. And in turn, the cicada serves the forest, aerating its soil across the years of nymphal digging, fertilizing it in the great pulse of the die-off, feeding the web of creatures that depend on the forest's bounty. The relationship runs both ways, cicada and forest, each shaping the other across the long span of their shared existence. The presence of a thriving cicada brood is in a sense a sign of a forest continuity. A brood represents an unbroken chain of cycles reaching back through time, sustained only where the forest itself has persisted across generations. A healthy, long-standing forest can hold a brood across the ages. A fragmented or destroyed forest cannot. The cicada's presence speaks to the forest's endurance, its broods, a kind of living measure of the forest's long-term survival. There is weight in seeing the cicada as bound to the forest's long health in this way. The creature is not incidental to the forest, but woven into it, a participant in its cycles, a beneficiary of its endurance, a contributor to its functioning. The fate of the cicada and the fate of the forest are entwined, each tied to the other across the long reach of time. To care about the cicada, then, is in part to care about the forest, and the cicada's broods persisting. Where the forest persists, stand as quiet witnesses to the long health of the woodlands that hold them their faithful return across. The age is a sign of a forest that has endured. When a brood vanishes, something irreplaceable is lost, and it is worth pausing near the end to weigh exactly what disappears when one of these ancient lineages is extinguished forever. The loss is greater than the absence of an insect. It is the severing of a chain of time. A brood is not merely a population of cicadas. It is an unbroken sequence of cycles stretching back through deep time, each generation having faithfully handed the count to the next, across thousands of years, a living thread of extraordinary continuity, an inheritance of precise timekeeping passed down through countless 17-year turns. When a brood goes extinct, that entire chain is severed at once. The lineage that reached back across the ages simply ends, and the great clock in that ground, having ticked faithfully for so long, stops forever. And what is lost cannot be recovered. A brood once extinguished does not return. The particular lineage with its particular timing and its particular history is gone for good. The forest that once filled with that brood's roar every 17 years falls permanently silent in that rhythm, the emergence that marked the generations of the people who lived there ceasing never to come again. A marvel of evolution, a feat of timekeeping honed across immense time, vanishes quietly, often unnoticed but utterly. There is real weight in contemplating this loss. We lose not just cicadas but a piece of deep time made living, an ancient, precise, irreplaceable phenomenon extinguished. We lose a thread of continuity that bound the generations of a place, human and cicada alike, across the long years. We lose one of the great clocks of nature stopped for good. It is a loss that asks something of us, a recognition that these ancient broods, for all that they are easy to overlook, are precious and irreplaceable, and that their quiet disappearance is the ending of something that took ages to make and can never be made again. What we lose when a brood disappears forever is a piece of the deep, patient, extraordinary order of the living world gone silent, gone for good. There is a lesson in the cicada that is hard to put into words, but easy to feel, a kind of humility that comes from contemplating a creature whose life is measured in decades, whose patience dwarfs our own, whose timekeeping outlasts our memory, and whose lineage outreaches our history. The cicada, by simply being what it is, puts the human scale of things into a longer perspective. We live mostly in the short term, in days and weeks, in the urgencies of the immediate, our patience measured in hours and our planning in years at most. The cicada lives otherwise. It commits without hesitation or distraction to a plan that unfolds across 17 years, a single patient arc of waiting and emergence, pitched to a timescale that puts every human impatience to shame. It does not rush. It cannot rush. It simply waits across a span longer than most of our undertakings toward a moment nearly 2 decades away. To contemplate this is to feel a certain humility. Here is a creature small and seemingly simple that keeps faith with a timescale we can barely hold in mind, that plans in effect in decades, and executes that plan with a precision and patience beyond anything we manage. The cicada reminds us that the short-term tempo of human life is not the only tempo, that there are rhythms in nature far longer and slower than our own, kept faithfully by creatures we are tempted to overlook. There is weight in letting the cicada adjust our sense of scale. Against its 17-year patience, our hurry looks small. Against its ancient lineage, our history looks brief. Against its faithful timekeeping across the ages, our short memory looks slight. The cicada does not mean to teach us anything, it simply lives its long, patient life, but in contemplating it, we may find our own scale gently corrected, our hurry softened, our sense of time enlarged. The humility of a creature that plans in decades, the cicada offers it, not as a lesson but as a fact of its being, and we receive it, if we are paying attention, as a quiet enlargement of our own sense of time. For all that science has learned about the cicada, and it has learned a great deal, the creature remains in important ways a mystery. Near the end of our 100 facts, it is worth gathering the open questions, the things we still do not understand, because the cicada's enduring mystery is itself part of what makes it remarkable. We do not fully understand how the cicada counts the years, how precisely it tracks the better part of 2 decades, and knows when the count is complete, holding that tally so accurately that millions emerge together. We do not fully understand how the prime-numbered clock evolved the path by which the cicada arrived at exactly 13 and 17 across its evolutionary history. We do not fully understand the genetic basis of the cycles or how populations switch between 13 and 17 years. We do not fully understand the manipulating fungus, how it bends the cicada's behavior to its purpose. And we do not know with certainty what a changing climate will do to the cicada's finely tuned timing. These are not small gaps. They sit at the very heart of what makes the cicada extraordinary, its timing, its evolution, its precise machinery, and they remain, despite long study, only partly answered. The cicada is one of the most observed and studied of insects, and still it holds its deepest secrets close, performing its astonishing feats by means we can describe but not yet fully explain. There is weight and a kind of beauty in this enduring mystery. The cicada is not a solved creature, its wonders fully accounted for. It remains, even now, a source of genuine scientific puzzlement, a creature whose most remarkable abilities outrun our understanding, whose clock keeps perfect time by mechanisms we are still working to read. The more closely we study it, the more clearly we see both how extraordinary it is and how much about it we have yet to comprehend. To know the cicada fully is to know, too, the limits of what we know, to hold its wonders alongside its mysteries, and to recognize that this ancient, precise, patient creature still keeps secrets that science, for all its progress, has not yet cracked. And so we come to the end, and to the image that holds the whole of the cicada's strange and remarkable story. Somewhere beneath the ground right now, in the dark soil of an eastern forest, the cicadas are waiting, a vast, hidden generation, counting the years ticking slowly toward an emergence still to come. A clock buried in the ground set ages ago, running toward a date no one alive ever chose. Think of it as you sit here. Beneath ordinary ground, beneath lawns and forests that look like nothing at all, millions of cicadas are living out their long underground lives, drinking sap, growing imperceptibly, holding their count, patient and silent in the dark. They have been there for years. They will be there for years more. And then on a night still ahead, when the soil warms to its threshold and the count is complete, they will rise all together and fill the forest once more with the oldest sound there is. No one alive set the date of that emergence. It was set 17 years ago when the last generation laid its eggs and died, set by cicadas, now long gone in a year, already past the clock wound by a generation that will never see it strike. The cicadas waiting underground now are keeping an appointment made before they existed, ticking toward a moment arranged by the dead, faithful to a schedule older than any of them. There is something in this that stays with you. The cicada's clock runs beneath our feet, indifferent to us, keeping a slower and deeper time than the time we live in. A patient, ancient rhythm ticking away in the dark soil toward emergencies, none of us arranged, and many of us will not be the same to see. The forest's loudest creature spends its life in silence underground, counting toward a date set long before, and rises when the time comes into a world that has turned over and over while it waited. The oldest enemy of our hurry is not danger but patience, and the cicada ticking in the ground toward a date no one alive set keeps that patience faithfully, as it has across the ages, waiting in the dark beneath the world for the year it will sing again.